Good morning. I don't see. Those- yeah. No, I don't see anything here. I see myself. And they're not looking at me. Good morning, everyone. We are about to start. Good morning and welcome to this session, and a very important session on geoinfrastructure, youth and geo-indigenous alliance. Here at ODOC 2026, we are continuing the ODOC sessions. My name is Letwin Pondo. I am User Engagement and Youth Coordinator for the GeoKnowledge Hub, and I'll be your moderator for the session this morning. I think one thing is becoming increasingly clear across the symposium and the sessions that the future of Earth intelligence is not only shaped by technology, by softwares, by satellites, by AI, or by data systems alone. It is also shaped by people, by communities, through collaboration and participation. And that is exactly why the specific session matters. So in this session today, we're bringing together conversations around youth engagement, indigenous knowledge, accessibility, open knowledge, and the role that the communities play with evolving geo ecosystem. As you're already seeing this momentum already across the various geo initiatives and activities, we recently had the Calibrate Earth Observation Challenge with Ghana. We also had the Geo Youth poster session competition. So we are witnessing young people using Earth observation and open data to address real world challenges and societal problems. We're also seeing growing excitement through other various initiatives that we're going to learn from today, from the colleagues here in front with me. So you have a very interesting lineup and different experiences from different organizations and different regions across the world. So with that, let us begin. Our very first presentation is going to come from none other than me. So I've already introduced myself already, so I'll just dive right into it. Thank you so much. Today I want to talk about a vital intersection that will also define the post-2025 strategy for the GEO community, the intersection of young generations and indigenous insights. For a very long time, many of us have treated youths as like end users of data, and indigenous knowledge and indigenous communities as passive observers of academic research. But today we want to kind of challenge that narrative by showing you how people, young people and indigenous communities are not just consuming the open knowledge, but are actively building, safeguarding and validating it even from the grassroots level. So there's this gap that I want us to look at during this first presentation, the gap that we have in open knowledge, where we have young people, where we have the youth, and we have open data and open knowledge at the other side, and we also have indigenous insights contributing to this whole scenario. We celebrate when a massive data set is made open to the public, but you know, when we simply tick the box of openness, we don't really solve the real world problems. We have other things that, you know, go missing, the links, they, you know, rot, metadata goes missing. But on the other hand of the spectrum, we have traditional funding models that are highly rigid and like they're just top-down models that dictate exactly how data should be used or interpreted, striping away its flexibility for these communities to use or to work across. But As you see, open knowledge changes all of those things because it allows access, it allows participation, it allows collaboration, innovation, and also inclusion. This one will be the end of us. Okay, thank you. So I have this, what we call the cycle, the knowledge cycle. So if you notice within our communities and within our organizations or our companies or wherever, it's usually the offices that make these maps, the dashboards, the outputs that we want the world to interpret the world as. We make them, we give them the outputs. This is the map. This is how you're supposed to go. This is where this is, which is not bad. But in majority of these cases, oh gosh. Yesterday it was hard already. Oh, okay, thank you. It's probably the proximity with the. Somebody can move them for me? It's probably the battery. I will, oops, sorry. You maybe they can, yeah, move them from that end. Yeah, okay. Go back. Go back. Back. Okay, thank you. Oh, next. Good, thank you. So I was saying it's usually the offices and our systems that make the maps. So we're taking them from our offices and imposing on the communities. We are just giving them those maps which are not flexible for them to like manipulate. They just have like, this is what is supposed to happen, or this is what is on the ground. We're taking this and giving it to the communities, and the communities have to work with that because we are the ones who are producing the maps. Next slide, please. But in essence, most of those things, I will not say all of them, but some of those things are not really working to what communities are really facing. For example, I'm working on a thesis that I'm trying to understand this intersection and how we are like not supposed to be imposing things on communities because they have a lived experience, some of which do not relate to the maps that we're just imposing on them. We have a community, I've just put an example here of a mother with a crying baby. The communities are crying in our hands, like, okay, fine. These guys are just giving us things to work with, but in essence, that is not how things are supposed to go. Next slide, please. So I would say the best or the better way or vision of working through it is coming from the community. Okay, communities, what do you face? What's going on? Talk to us, right? We have that conversation with communities and they define the boundaries and everything that we want to talk about, that we want to have in the conversation. And then we take them to the offices, now to our desks and to our so sophisticated ecosystems and softwares. And then we have something that doesn't only speak to our impact, but also speaks to the voice of the communities. And after we've integrated all this, we now come back to the concept that we've been talking about throughout yesterday of a knowledge package. We have everything and every resource brought together to form this kind of knowledge package. Next, please. So also the challenge that we have here, I had to reiterate it, that the challenge that we have is not youth interest, but the challenge is just access, inclusion, and support. I will not say much about what youth need, what they don't need, how can we support them. We've been having those conversations over a while now, but in your different ecosystems, you know how you can include the youth, how they can access, and how you can support them as well throughout this journey. Next. So I've just also highlighted here that open knowledge, it being open doesn't mean it should not erase ownership, it should not erase consent, or it should not erase cultural context. It's open knowledge, it's supposed to involve the communities. That means it's supposed to, if it means it has to be what do you call it, given credit to, you credit to the rightful people, you credit also to the right sources so that it doesn't lose its value along the way, along the chain of going through all these processes. Next slide, please. So the biggest question here that I think we should ask ourselves in all this is, who is still excluded from these open knowledge systems? We know what we're supposed to do, we know what they are, but who is still excluded from these open knowledge systems is what we are supposed to think about during this session, because open knowledge must also mean that something is understandable. People understand it. That's open. People can reach it. It's open. People can afford it. Now it's open and it's inclusive to everybody. Now we're talking about open knowledge. So in all this, we throughout the session, I want us to think about this very important question. Next slide, please. So I put here as next steps a little bit of points that we can also think about. We could institutionalize youth roles as data creators, not just as students or observers. We could fund knowledge packages of a short-term project. Short project dashboards. We should also respect and embed indigenous-led data governance protocols into all our systems and structures. That's in summary. Next slide, please. So in all this, the future of open knowledge is not only going to depend on satellites, on AI, on data systems or infrastructure. It is also going to depend on communities, on collaboration, on shared knowledge, on the indigenous wisdom and the young people that are willing to contribute. We don't own the work. We don't own the work, and we don't impose solutions on communities. Our job is to listen longer than it feels comfortable, provide flexible open building blocks, and empower the next generation to drive the change. We should just move past this rhetorical wand of openness and build data infrastructure that is truly great, deeply inclusive, and lasting. So with this, I thank you so much. And okay, thank you. Great, thank you so much. Moving on with our presentations, we are going to hear a presentation from Kwanele Ngongoma, who is based in South Africa, and unfortunately he couldn't be here with us this minute. So we have a recorded presentation of Kwanele that we are going to see on the screen.
My name is Kwanele Ngongoma. I want to start with a question, one I've been sitting with for a while. What does it actually mean to be a young person working with data that could change how your country responds to a flood, a drought, or a disease outbreak? The question is at the heart of why I'm here today. The session is about youth and about open knowledge and about what happens when young people stop being passive observers of Earth observation and start becoming contributors. I want to talk to you about the GEO Knowledge Hub, and specifically about the South Africa's Knowledge Hub, what it is, what it does, and what it meant for me personally to be part of building it. The GEO Knowledge Hub, or GKH, is an open source digital repository created by the Group on Earth Observation, designed to make Earth observation knowledge open, authoritative, and reproducible, not locked behind paywalls, not siloed in institutions, available to anyone who needs it. Think of the three pillars you can see on the slide: open data, freely accessible Earth observation knowledge for everyone, collaborative, built by and for a global community of researchers, governments, and citizens, reproducible, authoritative, verifiable knowledge that supports real-world decision-making. And at the global level, the platform organizes knowledge around the GEO focus areas, things like One Health, climate, energy and urbanization, weather and disaster resilience, ecosystems and biodiversity, land and water sustainability, agriculture and food security. These are not abstract categories. These are defining challenges of our generation. And now, through the National GKH, the same framework is being brought to individual countries, starting with South Africa. The South African Knowledge Hub is managed by GEO, the South African Group on Earth Observation, a forum that mobilizes South African Earth observation communities for societal benefits. The SAGKH is a dedicated portal where you can find Earth observation, specifically EO solutions, specifically tailored to South Africans' challenge. It connects researchers, government agencies, civil society, and the public to data tools that matter here in our country. And what makes the National GKH significant is not just a copy of the global platform. It is a localized, customizable environment, one that can reflect the identity, priorities, and needs of South Africa. Country-specific themes, local stakeholder networks, enabling mechanisms like Earth observation infrastructure and data governance. These are built into the platform by design. The goal is to make Earth observation knowledge not just available but accessible. Being involved in the development of the SAGKH was not a passive experience. It was an indication, one that no classroom had fully prepared me for. I want to get personal for a moment. There were three things I took from the experience. Complex project development. The first thing I learned was actually takes to bring a complex multi-stakeholder project to life. You have technical requirement, you have policy consideration, and you have community needs. You have to hold all of those simultaneously. You are constantly negotiating between what is ideal, what is possible, and between global standards and local realities. Data collection and curation. I was involved in working across various public sector databases in South Africa. That sounds straightforward, but in practice, it means understanding how different institutions structure their data, what standard they follow, and where the gaps are, and how to bridge them in a way that is useful and trustworthy. Global collaboration. I collaborated directly with GEO Knowledge Hub team, an international group of diverse disciplines and cultural backgrounds, working across those differences, navigating different ways of thinking, communicating was one of the most valuable experiences I've had. Together, we contributed to new features in this platform. Expanding information available on GEO Knowledge Hub made interface changes that improved accessibility and usability. Every one of these changes had a real-world consequence. It determines whether a researcher in Limpopo can find what they need, whether a student in Cape Town can understand what the data means. This is a small work. This is not small work. This is consequential work. The young people can and should be doing it. What brings me to the question this session is really asking, how do we equip young people to engage with open knowledge solutions and open knowledge systems like GKH? From my experience, two categories of skills matter enormously. Technical skills. You do not need to be a software engineer, but you do need digital fluency. Understanding how open data repositories work, being comfortable with the data formats, metadata standards, and APIs. Knowing how to evaluate data quality, provenance, and increasingly understanding how platforms are built so that you can advocate for features and interfaces that actually serve your community. That GKH itself is built on open source infrastructure, which means young people can contribute to its development. That is an invitation, but only if you have technical literacy to walk through the door. Data is never neutral. Earth observation data is powerful, but it needs to be interpreted within context. Social, ecological, historical, political. Young people need grounding in geo-focus areas. Yes, but also in how knowledge is produced, who it serves, and who it has historically excluded. This is where Indigenous knowledge perspective becomes not just relevant but essential. I believe that SAGKH, as it evolves, must create spaces for Indigenous-led approaches to be integrated alongside Western climate scientifically data. The combination of technical and theoretical skills is what allows a young person to go from consumer to contributor, from someone who uses a platform to someone who shapes it. The slide behind me lays out a practical pathway for any young person who wants to engage. Step 1, explore. Start by discovering EO data and tools on SAGKH that are relevant to your community. Visit the platform. Step 2, understand. Build your technical and theoretical literacy. Use GK learning resources. Attend SAGO community events. Engage with knowledge already on the platform. Step 3, contribute. Once you understand the platform, contribute data, improve metadata, and collaborate globally. Join the data curation and metadata enhancement initiatives. Step 4, shape. Be at the table when platforms, policies, priorities are set. Influence not just what data exists, but what questions that data is used to answer. This is not a distant aspiration. This is a pathway that is open right now to young people across Senegal and across the world. Let me close with this. South African Knowledge Hub exists as an intersection that matters, the intersection of open science, national capacity, global collaboration. It is a living platform, not finished, not static, but growing. Young people are not just the future beneficiaries of tools like the SAGKH. We are people who should be at the table when those tools are built, collecting the data, curating the knowledge, shaping the interface, and asking the hard questions about who the system is really for. This session is about fostering inclusivity and empowering underrepresented communities in GEO. I believe that starts with giving young people across South Africa and across the globe the opportunity to do exactly what I got to do. Real work with real impact on platforms that real people will use. Thank you.
Well, thank you so much. That was a presentation from Kwanele Ngongoma. He has played an active role in developing the South Africa National Knowledge Hub. So he was sharing from exactly his experiences in developing such a platform specifically for South Africa. We had more feedback yesterday from Dr. Zebola, who is also from the same initiative. So we'll move on next to our next presenter, who is going to be Andy Nelson from ITC University of Twente. Unfortunately, he's not also here with us, but he's a professor of food security and spatial agriculture at ITC. He chairs the GeoGlam Capacity Development Working Group and coordinates the Erasmus Mundus GAM Joint Masters Program, and is a senior editor for food security. I think the presentation that we're going to hear now is from Andy.
Hello, my name's Andy Nelson. I'm from the Faculty of Geoinformation Science and Earth Observation, also called ITC, at the University of Twente in the Netherlands. First of all, thank you, Letwin, for the invitation to join the session today on geo-infrastructure, youth, and the Geo-Indigenous Alliance. I'm sorry I can't be there in person, but I hope you find this video informative, and I'll be happy to join online the discussion at the end of the session. In the next 7 minutes, I want to introduce Geoversity, our open learning platform for the geospatial community, and explain why we think it has something to offer the conversation you're having today on youth and Indigenous engagement in open knowledge. First of all, what is Geoversity? Geoversity is an online, lifelong learning platform built by the ITC faculty at the University of Twente. ITC has been teaching geoinformation science and Earth observation for 75 years, with a long-standing focus on learners from the Global South or the majority world. Geoversity is the next chapter in that mission, a free-to-browse digital space where we publish courses, articles, videos and podcasts, and where partner organizations can host their own open content. Our ambition is straightforward: become the place where the geospatial community comes to learn. So who is learning on the Geoversity platform? And this is the slide I most wanted to bring to this session. It has a lot of information, and I'll pick out some of the key figures. In 2025, Geoversity reached learners in 174 countries. Our top 5 by traffic are India, Algeria, Bangladesh, Pakistan, and Nepal. Many of our almost 15,000 unique learners from last year are early career, students, young professionals, and people retraining into geospatial work. 97% of them say the courses are well organized, and 97% of them would recommend them to others. I mention this because the geo community has set out very clearly that youth and underrepresented communities should be at the center of Earth intelligence for all. Geoversity then is one piece of infrastructure that is already reaching those communities at scale, in their countries, in their own time. It's not a youth platform by design, but it is being used by the people that you want to reach. Geoversity has open content that goes beyond courses, so it's more than a course catalog. In 2025, we published 46 articles, 53 short videos, a podcast series, and 18 long-form videos featuring researchers explaining their work. That content all sits openly on the platform and on our YouTube channel. For a young learner who is not yet ready to take a 40-hour course, this is the on-ramp. Short, free, and easy to share. We treat editorial content as a deliberate way to lower the barrier to entry. Geoversity is also about partnerships that really work. Geoversity does not produce all of this content on its own. We host courses developed with partners such as NASA Severe, the Netherlands Space Office, the Netherlands Court of Audit, NV5, and the Vrije Universiteit in Amsterdam, among others. The Court of Audit course on geospatial auditing, for example, is offered free to supreme audit institutions worldwide. This is the partnership model. A credible partner brings the subject expertise, we bring the platform, the instructional design, and the learner community, and that content stays open. So Geoversity and the GeoKnowledge Hub, where can we connect? Where does Geoversity fit alongside Geo's own open knowledge infrastructure in the GeoKnowledge Hub? So the GEO Knowledge Hub holds open knowledge packages, data sets, and workflows from across the GEO work program. It's a really impressive repository of information and knowledge across a really diverse community. It's a really powerful asset. But reading a knowledge package is not the same as learning from it. Geoversity can help turn that knowledge into learning pathways. And the people who finish those pathways are exactly the contributors that the Knowledge Hub needs next. So to put this in concrete terms, what can Geoversity offer the GEO community through the GEO Knowledge Hub? Here are two concrete things that we would like to do with you. First of all, to co-design and build with GEO partners an Earth observation learning pathway aimed at students and early career practitioners and professionals. Part of this learning path will be short courses, providing basic skills and showcasing the intended learning outcomes of the whole pathway. Second, we'd like to amplify youth and Indigenous voices through Geoversity stories, short articles, podcast episodes, and video shorts featuring people from the GEO Indigenous Alliance and youth programs. If any of that is interesting, please do get in touch. The Geoversity platform is at geoversity.io. And Ledwin, again, thank you for including us in this session, and I look forward to the discussion.
Well, that was incredible from Andy. Also amplifying that we need to have youth voices and the Indigenous communities represented in all our work. Without further ado, I'll move on to our next presenter, who is here. You must be excited. We're going to move on to a presentation from Erin Martin on opportunities to make Earth observation data and tools more accessible for the youth. So Erin Martin serves as a member of the EOTech DevNet Secretariat through the support of NASA. An expert in strategic communications, program management, and partnership building, Erin has worked with international agencies, NGOs, and private sector partners on a wide range of development challenges. She has more than 2 decades of experience living and working in the Global South. She's a former journalist in U.S. Senate Press Secretariat and holds a master's and bachelor's degrees from Stanford University. So ladies and gentlemen, Erin Martin.
Thank you. Good morning. Are you out there? Are you alive? You're awake? Excellent. Thank you so much. Thank you, Letwin, for that generous introduction. I didn't realize you were going to read all of that, but I'm so glad to be with you today. And I think that potentially I'm going to be preaching to the choir here, because I think if you're in this room, you care about youth and you care about Indigenous knowledge, and you're thinking about ways to improve the situation that we have now. But maybe what I can say today gives you a few talking points for information that you can share and you can bring out. I'm joined by my colleague Martina Gorska, who's sitting in the front row with me. She's a partner in EOTech DevNet on the Secretariat through EO College, and she's based in Germany. I'm based in the US, and so we bring some great teamwork across the ocean. So I think moving to my presentation, I wanted to just tell you a little bit about EOTech DevNet. Oh, do I need the clicker? I'm in control myself. Voila. Okay, great. So just a word about EOTech DevNet, this organization with a strange acronym. It's the Earth Observation Training and Capacity Development Network. We were created 5 years ago. We're celebrating our 5th anniversary. We were born out of the CEOS working group on capacity development. Some of you may know CEOS. It's the Committee on Earth Observation Satellites. It's essentially the global association of space agencies. And they've been working on capacity development for a number of years and decided that there needed to be an effort to promote coordination and collaboration among the global providers of capacity building. And so you see the leadership partners are there. GEO, of course, is a very active member, and Paula here is on our leadership board, and we're so grateful for the engagement of GEO and our work. UN Office of Outer Space Affairs and 2 WMO entities, Education and Training and VLab, our leadership partners. And the idea is that all of these agencies not only have their own huge capacity building programs, but they also have vast regional networks across the globe. There are centers of excellence, there are training centers. And so the idea of EOTech DevNet is to really leverage all those resources and build on what exists already. And our aim is to think about extending the reach of EO capacity development globally. So we focus a lot on promoting best practices, on exchanging knowledge, and thinking about expanding access and uptake to this. Our key operationally, our key action areas are around communities of practice, and some of you in this room have participated already in our regional communities of practice that meet quarterly. We have flood working groups, drought working groups, and we've also spent a lot of time more recently looking at ways of aggregating information and pushing it out to the communities and making it more accessible. I'll talk about that in a minute, but that's a little bit about EOTech DevNet. I just want to emphasize that we've been supported by NASA and by the German space agency DLR for our entire 5 years, and we're very grateful for their support because it makes it all work. So why should you care? Why should anybody in this room? Why should anybody upstairs in the other sessions? Why should they care about youth and capacity building? Because it is our future. We all have a huge vested interest in whether the youth of today are prepared for the workforce of today, of tomorrow, of the day after. Who's going to take care of your health care? Who's going to take care of managing your parks? All of these functions increasingly are becoming more connected to geospatial information. And if we don't prepare the youth of today for that challenge, how are we going to survive ourselves? So we have a vested interest in this ourselves personally. But one of the things that's kind of interesting about the situation from what we've learned through EOTech DevNet and through our work with communities of practice and talking to agencies, government and non-government business, is that there really is a huge amount of capacity building available. There's a huge, you heard from Geoversity, but we could probably put another 10 agencies together to show you their extensive capacity building resources. And so the supply is high, but then we also know the demand is high, that there are lots of users out there who want capacity building around Earth observations, GIS, other forms of digital technology. And so, but we still have this huge gap in the middle of people not necessarily being able to access the tools. You know, the learning resources are a little bit fragmented. Richard's nodding, so I'm on the right track. And if you were here yesterday, you heard our colleague, Dr. Kofi from Ghana, also talking about some similar situations with the broader data environment. You know, we've got these challenges of languages, connectivity, not enough information locally tailored. And so we've got to figure out ways to disrupt this, you know, to build these barriers and move forward, to think about how we can help youth. Another key question to ask is, when we're doing this capacity building, are we building the right skills? And are we actually equipping youth with the skills that the workplace wants? This is a really critical question. And I've got some data here from EARSC, which is the European Association of Remote Sensing Companies. And I believe they're also upstairs presenting right now, but they do an annual survey of companies in the space sector to ask them about various challenges. And every year they ask this question about, are you having a hard time finding employees? And consistently, they find that, yes, it's close to 80% of having some difficulty hiring. So employers are struggling with this. And it's not just a European problem. Whoops, I skipped a slide. There is evidence that we see from other research that's being done that it's a global challenge, and that this study from IEEE GRSS talks about the workforce being 10 to 15 years behind. And we really have to think about how our role and how we can do a better job there. Also, similarly, from the World Bank, there's evidence from African business leaders that they are worried about the digital skills. We do webinars periodically. We've done a couple with GEO, which has been great partnership. And the things we're also hearing is that youth have a different demand for the kind of capacity building they want to see. They're more interested in hands-on training, practical guidance. They want more showcases and tools. And of course, there's strong interest in AI and really wanting to have customized learning paths. So perhaps the modalities that we've been using for decades need to be adapted a little bit. So here's what I propose. I think we have a lot of resources. We are in a position to make a lot of progress, but the thing we've got to redouble our efforts and recommit to collaboration, outreach, and innovation. And I think if we really keep these values in the front of mind, we can make a lot of progress. I'm going to give you a few examples of collaboration. Space for GEO is a fantastic 3 minutes. Where does the time go? Space, we can talk about this a lot more. Martina can tell you a lot about Space for GEO. It's a great partnership working concretely on developing skills and skills pathways. I mentioned EOTech, our work. We were spending a lot of time trying to aggregate resources to help with discoverability. We have a searchable database on places to find training, so you can visit our website, and I have some nice cards here we can share so you can find these resources. We also have trackers for droughts and flood tools, but it's a way of trying to just pull information together, make it more accessible. You know that there are a gazillion platforms out there that are already reaching youth, but are we linked and are we reaching them effectively? How do we leverage the work of the GEO youth community of practice and put our weight behind that to really build there? And that's something really critical to think about. Another key point is this idea about innovation. Remote Sensei is a really interesting initiative by EO College and Ignite Education, which is a German startup, and they're building these learning pathways so that a user can come to Remote Sensei and then plan their own curated education. But the question is, how do we get it back out to the community? Eve is another really interesting virtual expert that just launched this week. That will be interesting. How do we get it out to the community? NASA has a great program called Earthrise Developers Academy, which is a 10-week hands-on co-development process for early career people. So there's all these different things out there. There's lots of innovation, and we just need to figure out how we kind of loop it into this system. Another quote from that same IEEE GRS research that talks about bringing the collaboration together, bringing industry and academia together and thinking about how to do it. And I just want to say I was so interested thinking about when Sven was speaking about GeoGlam, thinking about the complexity of the GeoGlam environment and all the stakeholders that they have, and globally, politically, academically, tremendous complexity there. And they've spent more than a decade, a lot more than a decade, I think, working to build an ecosystem. And that's the same kind of strategic approach we need to take with youth, is we've got to think about it strategically. We've got to think about the broader ecosystem and how we can really support each other. So we're not doing webinars alone. We're not doing workshops alone. We're continuously thinking about how can the GEO Youth Forum support what the NASA RSET training program is doing, and thinking about ways to promote the resources, leverage the resources we already have. So innovation, collaboration, and outreach are my messages, and I hope maybe I have 3 seconds left. Thank you.
Thank you so much, Erin, and for the great timekeeping. But now you got me thinking. So that means I could be going with the right pace, but with the wrong skills set. Oh my God. Okay, this world is evil. Are those free?
Yes.
Okay. Give me. Thank you. Hello, good people. These are free. Do you mind? Distributing. Do you mind? Thank you so much. We move on to our next presenter. I don't know. The last time I introduced him, I was shaking, I was excited, I was screaming and all that, but I'll try to be calm today. But ladies and gentlemen, our next presentation is going to come from Richard Fu, who is a 17-year-old Chief Executive Officer of Helios. It's a London-based project launching a satellite into space to monitor urban heat islands. He is passionate about tackling climate change and the world of aerospace, believing that the field has massive potential to tackle our planet's biggest challenges. He's a member of the Royal Aeronautical Society and is enthusiastic about using small satellites to completely transform the uses of space. Ladies and gentlemen, Richard Fu.
First of all, thank you, Letwin, for the invite and the generous introduction. I am not as big as she says, but I hope. But I mean, today I'm hoping to sort of give everyone a gauge of what this project is, because it is, in my belief, very meaningful and something that is definitely worth talking about. Sorry, let me get my notes up just to. Oh. There we go. And also, thank you everyone for being here, and thank you for the incredible presentations we had. They were very insightful, and I certainly have a lot to hopefully add to the conversation. So before I jump into what the project is, I think I should probably also tell everyone a bit more about myself and why I'm getting into this. Because I remember about 7 years ago, actually sitting in an English lesson, listening to a presentation about endangered animals that really got me into environmental issues in general. And as I sort of discovered the issue further, I realized how complex and how massive of a challenge this tackling well, environmental issues, the climate crisis, everything is. And fast forward about 7 years, now here I am, because I genuinely believe now is the time that I can make an impact. Now is the time that I can take some action on it, and that is why we, some of my colleagues sat here today, are doing this project. So let me just jump straight into it. Yes, so we are tackling specifically the problem of urban heat islands, so extreme heat in cities. According to I believe it's the World Health Organization, urban heat islands and extreme heat costs about 500,000 lives a year, and I think we all should agree that that is 500,000 too much. And 2.5 trillion in damage, according to the World Economic Forum. And there are quite a few problems that we've identified through conversations with various end users. We need to have more conversations, by the way, but through the limited conversations we've had with end users, we've identified quite a few problems. First of all is the inconsistent data being used for large sort of cooling investment decisions. In no small part, a lot of different places, we are lucky to be here in Geneva, in London, where I'm from, and also in more developed cities, they have a pretty complete data set of urban heat, extreme heat, and different things. However, there is a data gap. A lot of different places, maybe cities that are rapidly developing, rapidly expanding, they might not have the complete data set required to fully make an informed decision about how to tackle this problem. And there are a few other issues. One of the issues is the lack of solution-oriented data. So there is not enough conversation, and yeah, as Erin said, we're probably preaching to the choir here, but there is not enough conversations we are having to end users, and that is precisely why I'm here today as well, to hopefully talk to a bit more different voices from different countries, from different places, and institutions, companies about this issue and how they are finding this tackling this problem of extreme heat. So this is the problem and the data gaps that we identified inside the urban heat ecosystem and the challenge that is facing us in terms of extreme extremities in temperature. So this is what Helios is. We are a CubeSat project. That's actually it's a cuboid. So I don't know what. Well, I think it's because the base is a cube. We're stacking essentially 6 cubes in a certain formation. It's about the size of a shoebox, and we have 2 payloads. We have a hyperspectral camera and a thermal camera. and it's going to be in orbit at 500 kilometers above the ground. We are measuring surface temperature, vegetation and water cover, and soil moisture, and we are expecting this to be likely 18 months in orbit, launching in 2027. These are the 20 cities. The map shows the 20 cities that we are targeting for this first mission, and about 380 million people live and work in these cities, so it's a pretty broad reach, and it's across the world, across a lot of continents. So that hopefully addresses the data gap in various places. And there is a 1 to 2 day repeat time and quite a high resolution, which I'm going to get to in a while, in a couple slides time. This is a kind of as well a proof of concept, because if this mission is successful, this shows that we can use this model to scale up and provide more data rapidly to other cities. The advantage of CubeSats specifically is that these are a smaller type of satellite that are cheaper to launch compared to many bigger modules, which costs millions of dollars or pounds. And that is why we have chosen this form factor, this smaller satellite, while delivering the same, if not a larger impact compared to cost. This is our model. You can have a look at it. I'm not going to delve too much into it because I've got plenty more information about the data, which is probably more useful to people here and people on the live stream. So this is the key data, as mentioned: land surface temperature, soil moisture, and vegetation and water cover. Those are our resolutions, and we would definitely like to host this on the Geo Knowledge Hub. This is our base layer of data, and it's worth noting that although the raw data for land surface temperature is 85 times 85, we are thermal sharpening it based on our soil moisture and vegetation and water cover data to sharpen it to 16 by 16. And we have a sort of example image. It's a very, very rough indicator of what how the resolution changes. The photo might not reveal too much, but in reality, the resolution is everything, because if you're able to deliver a higher resolution, that means that you're able to reach downstream users and local communities more, because you're able to monitor individual streets and individual districts, and therefore you're able to see kind of what the difference is between even the neighboring street, what the difference between the challenges that they face in terms of extreme heat are. In addition, we focus on solutions. These are some of the solutions that we have identified. The first one isn't really a solution, actually. It's development of urban heat islands over time. We're going to compare to existing open source data sets online as well, and within the GEO community. And yeah, these are some of the solutions that we are looking at identifying. And specifically, the way we're doing this is actually in two kind of layers. I will explain. So basically, we have a sort of layer A, and we have a type A layer and type B layer. The A layer is essentially life risk, because, as mentioned, 500,000 people die every year because of extreme heat, and so life risk, and this is absolutely not for compromise, should be free and should be uploaded and should be free for everyone to use. This hopefully will address the data gap that many countries and cities are facing. The other aspect is asset risk. So this is mainly targeted to insurers and companies and stuff, because they also do have their assets impacted by this. So this is the two kind of streams that we're going in terms of our layers. And more on the solutions that I was talking about just now, we're doing this in a sort of two-pronged way. The first one is to identify areas where solutions can be implemented through the data that we are collecting. So, for example, where we can reintroduce wildlife and reintroduce parks and maybe retroreflective services, etc. And the other layer is, and the third layer is solution impact. So identifying existing solutions, because we launch in 2027. So identifying solutions, how solutions are impacting, making a positive impact on cities is also equally as important as identifying places where it can be implemented. Yeah. So this is some of our team. The ones highlighted in orange are the ones that are here today. Some of my colleagues are actually upstairs in different sessions, but I have also got Sath and Sharon here, part of my team. And yeah, I'm going to stay on this slide for a sec, and I'm going to move to the other slide because there are more people involved. This is an incredible team. I'm very proud to be working with them, and yeah, you guys are amazing. Yeah, there we go. Cool. I'm going to move on to the next slide just to keep track of time, just to be conscious of time. So where we go from here, we have completed our what we call a critical design review, which means essentially our engineering design is complete. We are now building our flight software and getting it to 3D print. The next steps afterwards are assembling the model, testing it, and then we're aiming to launch in no later than Q2 2027. And well, as mentioned, we are here to, in no small part, learn because, as mentioned, there is a data gap. And so we want to hear from different communities, both upstream, the providers, and downstream, the users, how they are finding this problem, how they're finding connecting with communities, how they're finding listening to individual stories and things like that. So city authorities, meteorological and space agencies, and climate research institutions, I might also add the Geo Knowledge Hub continuing our partnership, and the GHRS, which Martin is, I think Martin's upstairs sharing a session right now, presenting a session right now, but the GHRS is one of our partners as well, and we would definitely like to partner with different people in this panel as well. So that is, I mean, there are lots of potentials to also, well, share data with different initiatives like, well, EOTech, DevNet, and share our experiences as well from this mission. So yeah, last but not least, these are our LinkedIn's if anyone wants to scan the QR code. Yeah, thank you for presenting. Thank you for listening to our presentation. And yeah, it's an honor to be here. Thank you.
Well. I didn't do anything wrong, you know. You just proved yourself, so I did nothing wrong. But actually, I'm a bit hurt, you know, on the focus countries that you have. Come on, you have me here, and there's no Zimbabwe on the map.
We will have Zimbabwe for the next one. It's a skill up. It's a skill up.
Okay, fine. We'll talk about that.
Okay.
But well, thank you so much. We're going to move on to our last but not least presentation from Diana. Diana Strategy is the International Strategic Liaison for the Geo-Indigenous Alliance and founder of Space for Innovation, working at the intersection of Indigenous-led innovation, Earth observation, ethical AI, biodiversity monitoring, and space research. Her work focuses on Indigenous data sovereignty, relational approaches to biodiversity, and the core design of technologies that respond to community priorities. And she's going to talk to us about next steps for Indigenous-led climate action through the Geo Knowledge Hub. Over to you, Diana.
Thank you so much, and thank you for the invitation and to all the panelists. Before I speak today about platforms, tools, maps, or data, I want to begin with something more basic, time. Because the work we're talking about today is not only about observing the Earth, it is about what communities remember, what young people are inheriting, and how technology can help us make better decisions. Sorry. For most of us, time appears simple. It is what the clock measures. It tells us when a satellite passes overhead, when a meeting begins, when a project ends, when a reporting deadline has been missed. Much of our institutional life is built around this kind of time: budgets, grant periods, deliverables. But the Earth does not move according to our project calendars. Rivers do not wait for reporting cycles. Animals do not move according to our funding deadlines. Droughts, fires, migration routes, grazing patterns, and ecosystems collapse unfold across longer, deeper, and often less convenient timelines. Even modern science reminds us that time is not as simple as the clock on the wall. Satellite systems themselves depend on a more complex understanding of time, movement, position, and gravity. For many Indigenous people, the idea that time is more than a clock is not surprising. Knowledge has long been carried through relationships with land and water, with animals and seasons, with ancestors, with young people, and with generations not yet born. Knowledge moves across generations. A satellite image may show the vegetation has changed. A sensor may record movement. A microphone may capture a sound, but a community may know when that change began, whether it is normal or alarming. what it means for water, animals, safety, or food, and what decisions need to follow. That knowledge may not always look like a formal data set. It may live in memory, in observation, in seasonal practice, in the authority of elders, stories, in names of places, and in the way people notice small changes before they become visible to institutions. This is why intergenerational knowledge matters so much for geospatial work. It is not about placing traditional knowledge beside modern data. It is about recognizing that communities often hold the context with which data remains incomplete. When young people use maps, satellites, sensors, drones, or AI, they're not only learning technical skills, they're learning how to read change across generations. They're learning to ask, what has disappeared from this landscape? Who remembers what was here before? What risks are becoming visible? What is missing from the map? And what decisions are being made today that future generations will have to live with? Geospatial technology is often presented as a way of seeing the Earth from above. That view is powerful, but it's not enough. In indigenous-led work, geospatial technology also needs to help us see from within a place, through memory, language, lived knowledge, responsibility, and relationship. That is where the real power of youth engagement sits for the Geo-Indigenous Alliance, not only in training young people to use tools, but in supporting them to connect with what is measured, with what is remembered. These tools maps, satellites, and sensors can reveal patterns that would be difficult to see otherwise. But as I mentioned before, data does not interpret itself. A map can show where something is happening, but it cannot always tell us why it matters. That meaning comes from people. It comes from those who know the place, those who remember its changes, and those who will live with the consequences of decisions made from this data. So the question is not only whether indigenous communities have access to geospatial tools, the deeper question is who defines the problem, who interprets the evidence, and who has authority over the knowledge produced. The Tomekatip is one example of this working practice. It was an indigenous-led project supported through the Lacuna Fund ethical AI work with field sites in the Ecuadorian Amazon and northern Kenya. The project brought together sound data, biodiversity monitoring, and AI, but the center of the work was not the microphone or even the model. The center was interpretation. In this image, young Shuar scientists are working with sound data and bringing uncertain sounds back to their community. This detail is very important. When a sound was not immediately clear, the answer was not simply to run another model or collect more data. This question moved back to the people who know back the territory, the elders and the knowledge holders, and community members with deep ecological memory. The Tomekatip helped create indigenous-led bioacoustic biodiversity datasets, but the sounds were not treated as technical data alone. They were interpreted through ecological knowledge, lived experience, and community authority. For me, this is also a story about youth. Young people were not only learning to use new technology, they were helping connect AI, sound data, and all their systems of knowledge. They became the bridge between the tools and the territory, between the model and the memory of place. Over the years, we have developed a new way of co-designing technology with and for indigenous communities through what we call the indigenous hackathons. The challenges do not begin with the technology, the challenges begin with the community. Elders help guide the questions, the youth bring creativity, local knowledge, and the urgency. Scientists, developers, artists, engineers, and geospatial experts then work around priorities defined by the community itself. And one example is the Namunyak app, a Samburu-led geospatial tool designed to help map wildlife, water grazing conditions, environmental change, and other observations that matter for local decision-making using only local symbols. In a landscape so arid that has severe droughts, and women and youth walk for days on end to collect water, the ability to share location of water can be a life and death situation. And this work now continues to evolve. We are now exploring collaboration with the World Environmental Solutions, who have developed technology to generate clean water from the atmosphere. One machine will be donated to the Samburu School, and with the youth, we will explore how the sensor data on temperature and humidity coming from the machine can support a local network for clean water and climate monitoring. And for me, this is what indigenous-led innovation means. Technology is not the starting point, the community priorities are. And this brings me to the GeoKnowledge Hub. For the Geo-Indigenous Alliance, the Knowledge Hub is not simply a place to upload outputs. Its value is helping us create a responsible pathway for sharing Indigenous-led methods. This means working with communities to decide what can be documented, what should remain protected, who gives permission, how the knowledge is described, and how others are allowed to use it. The point is not to extract Indigenous knowledge into the platform. The point is to help communities and geo-partners understand how Indigenous-led geospatial work can be shared with context, consent, attribution, and governance. So to conclude, young people are inheriting changing landscape, climate instability, new technologies, and decisions made before they had a voice in them. They're also inheriting knowledge, memory, creativity, and responsibility. So the question is not only how we train youth to use geospatial technology, the question is how geospatial technologies can help them carry this responsibility across time. If time is remembered, lived, and carried, then Earth intelligence cannot only be about observing the planet. It has to help communities interpret change, protect relationships, govern data responsibly, and make decisions with future generations in mind. And that is the opportunity for GEO, a deeper form of environmental intelligence, one that connects technology with memory, with authority, accountability, and responsibility across generations. Thank you very much.
Wow. Thank you so much, Diana, for this really inspiring insights. Time is more than just a clock. I'm learning. Thank you so much. We have a little bit of time for some questions, but we have to make it a bit quick. So let's see who has questions in the room. Who has questions? Let's just raise our hands so that we move from one person to the other. I see one hand, two. There's three. Oh, there's three. Okay, so let's start from the back. Then, oh, there's someone behind you. There's a lady behind you. Yeah, sure.
How it works. Hi, Dilek Kreisel from the International Institute for Applied Systems Analysis, and I'm also the Managing Director of the Citizen Science Global Partnership. I don't have a particular question, but I just wanted to say that I really enjoyed the session because it has all the keywords that I'm using in my work on a daily basis: community, youth, indigenous knowledge, and everything. But there was one missing: citizen science. So I wanted to bring that up into attention as well, because a lot of the things that you were talking about, probably we can tap into the power of citizen science and engage in youth to address all those issues like the data gaps that you've been highlighting, Richard, in your talk, and skill development and addressing environmental action and the environmental issues that we've been talking about in this session. Thank you so much. And just wanted to say that I would like to talk to you after the session if you have time, and maybe we can collaborate further.
Okay, thank you so much. I've taken note of that, but also to highlight that in as much as you didn't hear that specific word right now, we had a lot of that yesterday, which is not bad. Thank you so much for that. We come to you.
Okay, I have two comments. Yes, Latwin, in your presentation you mentioned something like research object. Maybe that will be good to look what is running under European Open Science Cloud, because there is hard work on the design of the research object like ROHAP and such activity in European Open Science Cloud. This is one thing. Second is a little, could be a comment. Yes, it is mentioned knowledge. Yes, but I think that most of the things which was mentioned here were more about sharing the data and information. Yes, knowledge for me is something a little higher, and probably will be good in some way to start combine this with the way, for example, what Felipe showed yesterday. Yes, to more included artificial intelligence, language model, metadata, to be able to integrate the things and to bring this to the people, because in many cases young people or also now farmers or another are not able to study thousand and thousand research documents. Yes, they have very often not skills to work directly with the data, but this new technology, which is now coming with large language model, generative AI, and another, I think that it could help really bring this to much bigger community. And I think that the yesterday presentation of the Felipe, but also from GRC, show something in this direction. And also we are ready to cooperate on this because we are trying to work on this concept. So I think that this could be something for future.
Okay, thank you. I'll come to you in a minute. I had a handsome, yeah, sure.
Hi, I'm Kayla Abrita from Servier. And I had a question around similarly to access. I was wondering if you could answer, how do we get vulnerable youths or indigenous communities involved in mapping when there might be a lack of technology access, or similarly but separately when mapping becomes political?
Happy to answer that question. Thank you. So that's the reason why we developed the indigenous hackathon methodology, which allows the communities themselves to co-design tech based on their priorities and needs.
Yeah. Go ahead, Paula.
Thank you very much. My name is Paola De Salvo. I'm a GEO Secretariat staff and a GEO Infrastructure Coordinator together with the team of Felipe, Kalamkas, Letvin, and Abdul, who is remote. I really would like to congratulate all the speakers for the very amazing presentation and amazing message you are been passing. And we are very, very proud, honored to be able to work with you all. You all mentioned from South Africa. Kwanele is not here with us today. He was supposed to be traveling from South Africa to come here. Andy from the Netherlands, Richard, Erin, and Martina, for which we are proudly collaborating, and Diana with the Indigenous Alliance. This proudness, yes, knowledge, Karel, you are rightly mentioned, is this combination of different data, satellite in situ, script, modeling, training material, everything together to be able to reuse it without much bottleneck. But I think, Diana, you highlighted something very, very important here. With the uptaking of new technologies, AI and everything else, why we are here today? We're here today because we are a community. We're a community and we have trust each other. We have this common good of a common objective to support our planet, to be a better place, to support the youth, to support and to work together, to co-design, co-develop, and in a community-based approach. And this is, we can have disruptive technologies, we can have amazing things, but if we lose that community power, we do nothing. And that is just a comment and nothing else. And thank you for being here.
Sorry. Okay, thank you. Thank you so much, Paula, for the intervention. Before you come, I just wanted to also add to your question on how we can get vulnerable youth involved. In my case, in one of the projects, because when we tried to, they don't have like smartphones in some of the communities, and for you to give them smartphones and try to explain the technologies of how they work, it was kind of complicated. And when you try flying drones, everyone ran away. Like, what is that? So it was just us in the ground, and then you would feel bad. So we just had to do like some paper maps. You just put the common roads and the common shops or anything that is common to them, and ask them, okay, just explain, this is your shop, this is your house. So from here, what else is there? And then they'll just put a dot and say, oh, there's a neighbor here. I have a neighbor who stays in the other side. And then you just try to orient the map yourself here, like, the other things. But that's how I could, or one of my projects could involve the youth, because in those vulnerable communities, because bringing all those technologies to them was like something else. But yeah, over to you.
Yeah, it's on. Okay. I have a question for Richard. So it's really impressive, all the work you have done. I mean, all the team that you are engaged. And sometimes that makes me reflect about, for example, that sometimes see youth like a really passive kind of community that they receive information. But my question is how your team speed up regarding all the information and skills needed to build like a cube or that kind of things. And also thinking about the global idea, like how that knowledge you having gathered with your team can be transferred or kind of connected with like South, Latin America, Asia, or other kind of South kind of hemisphere. So I don't know if you haven't think about that, or how is the situation from the youth in that part of the world. Thank you.
So thank you for your questions, by the way. It's great to have questions. So first of all, on how the team sped up regarding the information and skills needed to build this satellite. Honestly, a lot of things you sort of learn while you're doing it. So because of circumstances and people we're partnering with and sort of delivering things, we've had to sort of speed up learning. And well, I think for one, making good use of AI. AI helped a lot with sort of learning complex concepts, but also consulting partners. We're based in London. We have not just teachers, but people like professors. We did have a conversation with the professor from UCL a while back about sort of data collection and strategies, for example. So consulting technical experts, a combination of that, accelerating learning using AI, but also sort of different pulling in different people to teach us some crucial skills, and also just the existing skills. There are a lot of transferable skills as well doing this project from different things. I can't name an example off the top of my head. Let me think. So say, I mean, for example, to run this project, and I've done in my school previously things like model UN and that kind of stuff. These sort of skills are those skills that I learned from that are sort of transferable over to here. So using a combination of transferable skills, or consulting technical experts and sort of accelerated learning using new technologies, so AI, that's how we got the skills needed. In terms of how the knowledge can be transferred, honestly, we don't have a concrete answer to that yet. We are currently focusing on sort of delivering, talking to more end users, which are communities, local communities, especially as you mentioned in the Southern Hemisphere, because there is a data gap there. So how that knowledge can be transferred, we're focusing on sort of contacting and talking to more people from the Southern Hemisphere, and from that, I think we can extend further to young people through universities and research institutions, and also partnering with the great panelists we have today to connect to communities themselves through the incredible projects that they're rolling out. So yeah, I think a combination of that. Yeah, thank you.
Thank you.
Thank you. Thank you so much. I think we have exceeded the time, and but well, thank you so much for attending this session. If any of you has any other questions or interventions, please, the panelists here, I'll make them wait so that you can talk to them. But well, thank you so much for the interventions and all the comments. I want to urge you not to leave this room only inspired, but also I want you to leave connected, challenged, and ready to contribute. I want you to think about this conclusion, as we have heard from the different speakers, that The future of open knowledge and Earth observation or Earth intelligence cannot only be built by technology alone. It will be built by people and people at the center of it all. But well, yes, thank you so much for attending this session and thank you for all your contributions and for paying attention. Thank you so much. I guess we have a break before the next sessions. Thank you so much and see you around. Thank you.
Sorry about the next session. Okay, next session is going to start soon. So 5 people, and then the last 2 people sit over there, right? So that that's what is that fine? Maybe you and Genki-san, you sit on there. That's fine. That's fine at this point.
I will be the timekeeper for
Okay,
this
I see.
session. You
Okay.
need something special or?
Right.
Okay.
Yeah, we have 10 minutes for each presentation.
Okay.
Maybe 8 minutes and then 2 minutes for the question and answer.
Okay.
So that's it.
Perfect. Hi.
How are you? That's great.
See you. Nice. Sorry, we're
No problem. Good. Just we are going to start very soon.
Come. Rangela.
Angela, so nice to meet you. So sorry, I'm a bit hurry.
Is that the speaker here?
It's the first speaker. But, so
This is a lucky chair. This is a very lucky chair. I encourage you to sit there. Oh, okay. I appreciate luck.
So let's get started.
Good.
We are ready to start for EO4 SDG session. Please have a seat, please. And then I just wanted to the speakers, most of the speakers should be here in order for the presentations. And then, but we need 2 other chairs sit on there. Monica, yeah, you are with, yes, Manuela. But yes, as much as speakers, you should sit here.
And then after I'm done, I could.
Yeah, you can
leave.
just switch.
I
You can just switch.
with
Right.
whoever's left.
Exactly. Exactly. Okay. Let's. Okay. Then yeah, you're here. Okay. Thank you very much. All right. Let's start about our community event. EO4 SDG initiative progress and plan for post 2025 GEO work program leverage EO and AI. So my name is Osamu Ochiai. I'm from the Japanese Space Agency JAXA, and then we are the joint moderating with Dr. Lijun Tsuo from the China Academy of Science. Is it correct? So because the seat is very limited, so she's sitting here. So today we have 6 presentations, just you can hear, and all the presenters are now here. So thanks very much for the, squeezing the seats. And then we have a 6 presentation, and then 10 minutes each, maybe 8 minutes, and then 2 minutes for the question for each. And then, but we are flexible. After that, I'm passed over to my co-moderator to have a panel discussion, and then audience question and answers, and then summarize the session. This is very simple, but yes, that's our session. And then we have a slides. Who is running the slides? Yeah, but someone needs to initiate because I need to have some introductory slides, but no one there. That's funny. Okay, someone needs. Felipe, can you help? Okay, that's great. Yeah, just during the coming up for the slides. Yes, I'm also the co-chairing for the EO4 SDG initiative currently in the GEO work program, and we are now planning to just a new GEO work program for the post 2025 is now under planning, and then EO4 SDGs, as you may know. This is going to be a renewable, and then it's now on the one of the enabling mechanisms in the work program. Still, we need to some coordination about how to run the process. So we have a kind of a quarterly teleconference to organize how to run this program. I don't want to detail discussion about how the work program should look like, but this is we really like to hear about what you are now doing about this. And then we can discuss how the future EO4 SDGs in conjunction with EO and AI is really the main topic to discuss about how we can encourage the community is more moving forward. Okay, so let me just, this is event concept. I don't want to read everything, but you may know that post 2030 agenda, SDGs, is going to end up 2030. So we still, we have less 5 years to have a global agenda. So right now, I think the UN and the framework is now under evaluation. How much SDGs goal targets indicators are being achieved. And then some of you may know that it's not so much good progress. We have 17 goals, 200 indicators, and 200 more indicators, and target is 100 something. And then, but not much progress has been made. And Earth observation is tools that making a progress. And then sometimes we can satisfy about the targets and goals, but mostly for the indicators to measure how much progress has been made for the goals, SDGs goals. So there are lots of activity currently ongoing for the GEO for SDGs, and there are many providers and the processors and also the stakeholder indications. And we have also engaged with the UN Statistic Office, UN GGIM. This is really important that we have been done so far for the New York City discussion on how the geospatial data can be contributed to for the SDGs monitoring and the progress for the SDG goals and targets. So we really like to hear about what's happening in your community. So because this is a very diverse 17 goals for the biodiversity, water, climate, urban, blah, blah, blah. So there are a bunch of diverse activities going on, but we really hear about the Earth observation community is quite essential, very active, and so that you need to loud the voice about we are the main power for the SDGs. So that is what I really like to do. And then given the situation is going to be changed because this is one of the big topic because the technology change, innovation is one of the other aspects because AI is coming, how we can be more proactive manner for the EO plus AI is one of the very innovative elements to discuss how we can more effectively, adequately short-term burden of the processing times and the producing about the Earth intelligence for the SDGs is one of the big topics to discuss. As China colleagues, there's quite a huge amount of the activity ability to do so at this point in time. Okay, so then this event is, again, we really like to hear and make sure about the progress which has been made through the EO for SDG initiatives, but not just only for this. We really need to characterize about what is our next steps in the situation for the going to end up 2030 agenda in next less than 5 years. So this is what we need to discuss. It's kind of a little complex situation at this point in time. Okay, so let's get started. I'm going to end up my talk, and then we have 2 moderators, myself and Lee Jun Tsuo, and then we have 7 speakers ahead. one is only the video presentation. Okay, and then we have agenda. And then we have a panel discussion. We have 4 questions already prepared, and you are in mind how to answer those things by the Region 2 is going to ask. Okay, let's get started. But first presentation is a Pat from the Esri, big company, big GIS company, not just only GIS maybe. But so, floor is yours.
All right. Well, thank you very much. This is such an important topic. The SDGs really have such potential to have positive impact on the world. And we know, as Osamu was saying, many of those require Earth observations data, spatial data, and the analytics to go along with that, to understand the goals, to understand the situation and inform actions to advance and make progress on the SDGs. And as he was saying, that can be very empowering. And part of that empowerment is really building the capacity of many people who are focused on water or on air or on developing rural areas and access to many critical resources. So one of the things that Esri, we're a GIS software company, Earth observations, analytics company, and doing more and more with AI and Geo AI. But a lot of what our focus is too is we create the software, but we also invest in building tools to build capacity. So enabling people to take these tools, have access to data, and apply that to whatever the challenges that they're focusing on. So I am representing my colleague, Carmel Turborg, who's been involved in the EO for SDG work group of GEO for many years and leads our activities with in the SDG area. So we decided the most important message we could convey is informing you, sharing a lot of the learning and capacity development resources that are out there and available to all of you right now. So we're going to focus on leveraging those GIS tools and skills, these pathways for the SDGs and beyond. So I will run through a number of examples of this, and hopefully you're familiar with them already. And if not, maybe you'll learn something new and be inspired to go home and become a student and apply some of these resources in your own situation. As you were saying here, the 17 goals, 69 targets, 231 unique indicators, there's a lot there. And we all know that many of these targets and indicators would benefit from the information from spatial information, a spatial perspective. So they're informed by geospatial data. And once you do that, once you embrace that idea and leverage some of the resources that are available in your countries, that are available from other organizations, Esri and others, you can start to put together more meaningful resources to engage the public, to engage leaders to understand. And this is just an example of some of those countries who have embraced the geospatial data and analytics to help inform some of the SDG work they are doing in their countries. This is just an online portfolio of several different countries that have done that. So we've worked with many of these countries, and we have built this kind of online platform and a template to say, if you're working on SDGs, here is some using global data so any country in the world could get a start with building a portfolio of SDG related data to inform different targets and indicators there. And this is just an example of the portfolio from these few countries. And if we just pick one of the countries here, Burkina Faso, you can see that there's kind of a template view. It leverages, so it's easy to replicate and then say, oh, I can use global data to look at change in, in the kind of the livestock or crops or biodiversity. But then if a country has their own data, they can add more detailed data to fill in additional maps. The templates include tools that will allow you to do that swipe to compare two different time periods or different data. And the other thing that's very nice about this template of the kind of, we call this an executive portfolio, because we try to make it executive proof. A lot of times we're asked to share information with our leadership, but they don't really understand how to navigate even a dashboard sometimes. So this is very friendly, iPad friendly. So no typing required. You can touch, you can scroll through, go back and forth between maps. And this is free and open template that any country, any organization could embrace and make their own and customize as they go along. So I wanted to give a kind of that view of, as you get involved in this, what does a kind of a final product or an evolving product look like to explore those maps. But if we step back and look at the indicators and start to think about, okay, for those targets and indicators, what kind of data would we need? Oftentimes it's common data like population data and land cover data, a lot from the satellite imagery, location of critical infrastructure, kind of where conflicts are, marine areas, protected areas, lots of the common data that your GIS counterparts, you might not be, the SDG leads may not necessarily know about this data, but if we make just a general list, then we can move into, and I know this is a bit small, but that's kind of crosswalking that list of population. Well, where do I find that population data? and assembling links to the live data from many different authoritative sources. And there's a growing collection of that data that is available. And some of that data is what's fed into those templates that I showed you earlier for a few of those countries. But how do we, click happy finger there. So then when we take that general data, how do we translate that to speak to specific SDG indicators like this 1411, the index of coastal eutrophication? Now this one you kind of get off easy because GEO Blue Planet, along with NOAA, with UN organizations come together to say, how can we take global data and do the calculations, prepare the maps that will help with this, with 1411 on eutrophication. So there's an entire collection, a hub collection of data and maps already generated to address 1411. And the same with 911, looking at rural access, the rural access index, kind of accessibility of rural populations. This is all work that was led by a following methodology put out by World Bank that's already been translated using data, global data. So it's summarized for every country. You already have kind of your indicator for that topic. Same with malaria, 3.3.3, the incidence of malaria per 100,000. This one, another, like we talked about the capacity development, this is a learn lesson. We've been creating many of these learn lessons where you can go there and it'll walk you through the process. How do you calculate the malaria incidence for my country? So that's a online learning tool. You can go through that. There's another one that's in the this one is a story map created by FAO that goes through the Green Mountain Cover Index and how to calculate that. So this is an interactive story map that walks you through the process. So then they have also created training materials to go along with it. 11.3.1, the ratio of land consumption rate to population growth. This is, I wanted to put this one in here. So if you're looking at one of these indicators, first you just think logically, what would I have to do to, to accomplish this? Kind of lay out your general steps, and then you can move into, oh, did I go the wrong way? Oh, no, I didn't. Sorry. And then it translates into these specific steps using those tools. And I don't know how I'm doing on time. 2 minutes. Okay, I'm going fast. Then wait, so this is then translating those general steps into calculating that degree of urbanization. And this is in partnership with the EO for SDG work group, with UN Habitat and JRC. And this is a calculation that is being done now, and or it may actually, it will be added to the toolkit, so everyone can find it there. And all of these resources are linked from that Sustainable Cities and Human Settlement Toolkit. And then I just wanted to say, oh, and you brought up the AI. We're doing more and more on how can we apply AI and deep learning models to do classifications, to kind of pre-package these training models to calculate different things from Earth observations data. So you can look at solar potential, you can look at crop classifications and other things. So many of these learning models are out there and available. And this is the kind of the take home is, where do you find these? We have the SDG Geospatial Learning Lab that we've put together with SDGs Today. And so there you have all of these learning materials in one spot with the tutorials. And there are a couple different ways to access these depending on what it is that, if you just want to learn basic information on how to get started, we have 2 pathways. If you're just getting started, you click on the left. And if you're an experienced user, you click on the right, and it takes you down a different learning path. And then within there, you have different learning objectives, and you can just jump in on whichever tool or skill you want to learn today. So you can start out with exploring what are the resources in the free and open ArcGIS Online. You could click on number 2, and it's how do you build a survey? Maybe you need to survey your community. If you click on number 3, it's how do I build a map? You could go on to how do I build a dashboard and so on, how to do some analysis. So any of these learning tools are incorporated into this learning resource. If you are a little more skilled and want to really get ideas on whichever indicator is particularly of interest to you, you can go to this page and click on any one of these goals. And it will take you to an entire collection of resources focused just on that goal. So many ways to maneuver through all of the resources that are out there that help you get to the point that helps you kind of meets you where you are, whether you're a beginner, more advanced, if you want to learn from what others have done on a particular target, or you just want to build your general kind of GIS and analytics skills along the way. A lot of free open resources out there for you to take advantage of. Thank you.
Thanks, Pat. Really great tools, and then toolkits, and also the how to the skills needs to be communicate to each other. And just one question from the audience, if you have. Okay. One. Yes. Oh. Two. Yeah, let's be quick. Yes, you go first.
Yes, in the plenary before we heard a lot about trust, etc. What happens when a country sees the dashboard and says, well, wait a minute, is this the correct number for me? How do you balance the trust, local data, ownership, etc.?
Yes, that's a very important question. And what I didn't get into in all of our learning materials, we have full documentation. Like one of them referenced, this is implementing the World Bank methodology for whatever indicator that was. So we follow any authoritative source in the methodology outlined, and all of the data is documented so you can go back and validate what the inputs are. So we try to embrace whatever we put out will be fully documented and follow the authoritative source. Or we work with partners like on the eutrophication, where it's GEO Blue Planet along with Esri as an implementer, but they are the experts in the methodology and the data. So all of it is documented so you could work back to validate those findings.
Thank you. One more. Yeah, go ahead.
I was going to say that I can find you later, but okay. Because I'm building the same, but for education purposes, is any copyright thing that I need to be aware of? But
everything out and share it openly, but we also work with partners on every learn lesson that we make. We do not do it kind of in a vacuum. We don't want to build anything that doesn't meet the needs on the ground. So in all of the open solutions we build, we do it hand in hand with partners. So maybe there's some opportunity we could work together on that as well.
Absolutely. Then we will talk later.
Thank you.
Great cooperation. So let's move to the next presentation. So next one is Dr. Langela Barry Swain. So you have our floor, and then could you please introduce yourself?
Thank you, Osamu-san and Professor Zhou, for putting together this very useful panel. So what I'll try to do, well, I'm a professor of economics and also research director at the Center for Sustainable Development Research at the Stockholm School of Economics. What I would like to do in the presentation now is to connect to some of the issues raised by Patricia, but also give context to the speakers that are going to be introduced in the panel later, and discuss about why are we using artificial intelligence for analysis, for data collection, and how exactly does it, where exactly it is in context of the Sustainable Development Goals, and especially when we are discussing the progress of these goals and also placing it beyond Agenda 2030. So the presentation is going to be about measurements and to system transformation in the global sustainable development as we know it. So it's about evaluating, but also discussing about how we are going to think about the post-2030 world and its agenda? And are we going to be thinking about replacement or... So if we look at the evolution of the global development frameworks, and this is work that I do together with colleagues at Indian Institute of Management in Ahmedabad, we have looked at data over time for the development paradigms or development frameworks that we've had internationally, beginning from the 1990s with the Human Development Index, then the Millennium Development Goals that came from 2000 to 2015 and developed or transformed into a more expansive, universal way of looking at development with the Sustainable Development Goals. And then with the Paris Agreement, with its focus more on the environment, and now looking at the Beyond 2030 agenda. What is it that we are doing? Are we looking at new ways of where we have to go? Or is the core of the goals same? And what we've done is we've empirically looked at this using network analysis or system analysis. And what we find is that irrespective of how we have been evolving the global development frameworks, the core of development goals has remained same over time. And so it is still about removing poverty. It is still about, at the very core of development, it's still about, basic health, education, and then we have like a continuum or a bridge in terms of finance, in terms of infrastructure, and in terms of governance. And then we have a periphery with the various environmental objectives and goals coming in, which is not truly getting integrated. And that's exactly what we are or should be looking at in the future beyond 2030. So in this paper, what we are discussing is the main message is when it comes to goals, we are not going to have a major transformation in terms of what we expect to achieve. It is going to remain similar. What we really need to see a transformation in is to integrate the environmental and other goals in a much better way, using finance, using governance, using institutional settings into the core development, into the core of development. So what are the challenges as far as monitoring the progress of sustainable development goals is concerned? As was mentioned, we are talking about 17 goals. We're talking about 169 targets, 231 indicators. But the challenges that we have are mostly in terms of the measurement gaps. And these measurement gaps are in terms of missing national data. It's in terms of weak time series that is available for different countries. It's about limited comparability across different countries and regions. And it's about the policy usability of the gap. Like you mentioned about the easy access through the iPad to the data. And so how do you make the data more accessible, more usable? The second point that I want to mention about, understanding and measuring the progress of sustainable development goals or any agenda that looks beyond 2030 is the fragmented indicators. We cannot, it doesn't make sense to measure the progress of different objectives in isolation. So you cannot look at goals as silos. We need to be thinking about development and the different goals as a composite, as goals that affect each other, get affected by each other, and hence are interlinked to each other. So fragmented indicators that only measure one specific goal doesn't make much sense. What we need is indicators that measure on the system of goals that are working together, whether they negatively affect each other or positively affect each other. And then the third point that I want to make is about weak implementation. So in terms of the measurement challenges, we also need to look about how we can make the implementation of measurement, monitoring, and the progress of these goals and governance of these goals more implemented
and hence having an impact on the ground. So in the previous session, we were discussing about communities. How is it relevant for the communities in various countries? How does it affect the indigenous populations? So as many of my colleagues in the panel are going to be speaking about, they're going to be looking at various ways in which artificial intelligence can be used for data collection or analysis. And so what we have out there is satellite Earth observations. We have use of AI in terms of processing. We have the Sustainable Development Goals dashboards as you have developed. And many of these things are to meet the challenges that we face in terms of missing data or in terms of addressing and making the data more accessible. But I would also like to point out to another recent research of ours. This is with my colleagues at IGES in Japan. And there what we are discussing is that it's very hard to measure, to monitor 231 indicators. So whether we are talking about the Sustainable Development Goals or we are looking at beyond 2030, what we should do is also, so we have given one example in our research. This is the society framework where we look at specifically, each of the letters in the word society stands for a principle that we use to evaluate the indicators. And so by focusing on the state or outcomes, by focusing on the coverage for the populations, looking at how well integrated the indicators are, how explicit, transparent, and clear their definitions are, and also how easily they can be measured. We have identified 52 indicators, and hence what we are saying is that into the future, we don't really need very complicated indicators. What we need is indicators that try to measure the interlinked systems more effectively, and they're relatively few, so that we can effectively monitor them. So moving on from that, I would emphasize that we don't need to think about silos in terms of measuring each sustainable development, but about indicators that measures the systems. Think about how well they can be used for governance purposes and how embedded they are in the institutional infrastructure. So what we need to do is to move away from sustainable development challenges and make a systemic shift towards integrated system approach. To conclude, I would say that what we have is a shared language, a common metrics, a coordinated mechanism that the Sustainable Development Goals have given us. So that is something that we need to preserve as the institutional infrastructure or institutional capital that the Sustainable Development Goals have built. So whilst we are looking towards transformation in terms of architects of achieving goals, sustainable development goals, and also beyond 2030, we don't need to lose this infrastructural capital. We need to build on it. So, and at the same time, what I'm also emphasizing then as my final message is that the pathways beyond 2030 then need to be system-based indicators. It has to harness the power of the Earth observation, AI data infrastructure, and governance and accountability ecosystems for monitoring the progress. But I would stop with the final message. The evolution of development frameworks over the past 2 or 3 decades has shown us that the core of development goals are the same. What we need is better integration of the layered goals that we have continuously put over the system, the core of the development, and that integration has to come, and we have to meet those challenges with the help of AI or with the help of governance or infrastructure and implementation. So I'll stop there. And if you have questions that you can't take care, you can always reach me at my email. Thank you.
Great presentation. Thank you very much, Lanjula Santos. This is really deep insights about how we can improve or evolve about the future beyond the 2030 SDGs process. Just in interest of time, one question. Yes, please.
Thank you for the presentation. I have a question regarding the politics that are involved in the development of these goals and the indicator frameworks and so on. Have you considered them in your work? Because the way you're approaching this is a little bit of a technical and scientific perspective, which is great, but there's also these other political issues that have been involved in them in their development processes.
I mean, thank you. I think you raise a very important point. I mean, all of us are aware that important concepts like religion and, for instance, population don't even enter the Sustainable Development Goals, never did. And then given the past pandemic situation and the geopolitics, some of which is ongoing, there are challenges. However, as I pointed, the core of what we want to achieve is not going to change. So the geopolitics of it might affect the implementation, may have implications on the governance, but it shouldn't have an impact on where we want to go into the future. If we are still focused on sustainable development, if we are still focused on meeting the challenges of climate change and basic challenges of development. And I think that the persistence over time of these goals, especially the core values and some of the other layered values in terms of finance, in terms of infrastructure, in terms of environment, these have not changed. We just need to integrate them better within the limitations of politics.
I think this is a very important discussion, how we can probably communicate with the policy level and our system level or data level. And this might be, given the world changing, and then SDG is a kind of a big discussion how to support the entire community. But for us, we are the kind of a geo community. We provide some sort of information how EO data can be supplied to support for the realizing about the SDGs. So we may need, let's discuss about the panel discussion is more because it's a really important topic for I like to maybe after the presentation, I like to hand over to this important topic in our co-moderator. So let's move to the next one. Next one is it's going to be a pre-recorded presentation by FAO, Dr. Lorenzo Di Simona, having a recording presentation. So can you start it about the next one? Yes.
Good morning, everyone. My name is Lorenzo De Simone. I'm a technical advisor for Geospatial at FAO's Agri-Food Economics and Policy Division and team leader for EOSTAT and Estella program. And I'm also a member of the EO for SDG group. And I'm here to present from Rome today because I could not join you in person. And I would like to present two innovative solutions which I believe represent a step change in what Earth observation data can do for SDG2, not just as a monitoring tool, but as a real infrastructure for agricultural policy and financial inclusion. As we know, SDG2 is off track, and part of the reason is a data problem. Traditional agricultural data systems face a fundamental bottleneck. They require detailed biological inputs biophysical inputs that simply are not available in data-sparse regions, and surveys are too infrequent and too costly to inform timely decisions. So the consequence is stark. By the time a crop failure appears in a statistical table, the critical intervention window has already closed. So Earth observation big data changes this because satellite offers synoptic repeatable measurement every week, every season, everywhere. So the question is whether we build tools that turn these measurements into decisions that actually save lives. And this is what crop PI and GeoCredit are designed to do. So the crop PI, crop potential productivity index, assesses whether assesses what land can actually produce for a specific crop based entirely on biophysical conditions. It integrates three inputs: climate suitability at 30%, water availability as the ratio between evapotranspiration to potential evapotranspiration at 50%, and soil quality, hence pH, organic carbon, and water holding capacity at 20%. A single worst performing month or drought or heat stress pulls the entire index down, reflecting biological reality. Okay, so what you see on this slide is the live crop PI application running on Google Earth Engine. It is publicly available and operational today. So a user can select any country. Here, for instance, we've selected India, and any crop between among wheat, maize, and rice, and any time window between 2001 and 2024. And optionally stratified analysis by farmer size or by field plot size. So in this case, the map renders crop PI at 250 meters resolution across the entire country of India. The time series panel on the right shows mean crop PI by farm size, class over 2 decades, and we can see that the larger farms in the 10 to 50 hectares range, they consistently outperform smallholders below 5 hectares, are direct policy relevant signals for targeting support. This is not a research exercise, it's a production tool, freely available, covering any country in the world. How do we know that crop PI works? Because we validated crop PI using two independent approaches. In Malawi, we used a process-based model called the DSS-SAT-CERES. We ran simulations for 70,000 grid cells for maize at a 1 kilometer resolution. Then the average simulated yield of 2.6 tons per hectare was aligned with USDA reported values. When we regressed crop PI against simulated yield across 5 production classes, the R squared was 0.75, meaning that the crop PI could explain 75% of maize yield variability at the national level. In Ethiopia, we tested spatial agreement between net primary productivity from FAO's Vapor dataset across all districts, and every year between 2012 and 2022. And Wilmot's D-stat values ranged between 0.6 and 0.8, meaning a strong, consistent spatial correlation over a decade. And in terms also of resolution advantage, we see that the local scale, for instance, Dedra district in Malawi, crop PI reveals productivity ranges between 30 to 80s as a score, whereas existing agroecological global models, they usually identify just a single value for the entire unit, meaning that crop PI sees what other global products can't see. Crop PI is globally available and is operational across 11 countries through pilot projects, with which we try to support 3 distinct policy functions. So spatial targeting, identifying high potential low yield zones and guiding investment in inputs and irrigation to maximum return areas like the Nigeria savanna. Early warning, so crop PI tracks dynamic seasonal shift before the harvest. In Togo's Chamba district, crop PI increased from 68 to 73 between 2021 and 2022, an actionable trend data for planners. And policy accountability, so by combining actual yields against crop PI potential, governments can track whether investments are genuinely closing the productivity gap. And finally, with the flagship example in Zimbabwe, where crop PI and Earth observation, drought monitoring are connected directly to a geospatial farmer registry system, linking high-resolution indicators to individual farms, parcels. And this work has earned FAO the 2025 SDG Innovation Award. Now let me turn to GeoCredit. An estimated 750 million smallholder farmers globally are invisible to the financial system. Not because they are poor farmers, but because traditional credit scoring requires historical financial behavior, formalized income, and tangible collateral. They have none of this. So the result is information asymmetry and credit denied. But here is the key insight on the right-hand side of the slide. A farm depicted by the satellite is visible, even when formal financial record is not. Hence, satellite data can reconstruct the planting history, the climatic risk exposure, and seasonal crop performance for any georeference farm. This is a credit profile. GeoCredit asks, can we use this visibility to break down the wall? To test this, we ran a proof of concept pilot in Kenya with Mkulima Score 360, a credit scoring platform startup, national startup, using 95 anonymized smallholder borrower records and strict data governance protocols. We built two parallel models, a baseline using only traditional financial variables and an Earth observation augmented model, adding satellite-derived features including NDVI time series, enhanced vegetation index, leaf area index, and rainfall anomalies. The results are on this slide. So the Earth observation augmented model achieved an area under the curve of 0.846, which is an industry standard for excellent discrimination. That is an improvement from the baseline of 0.776. Cross-validation variance dropped by 36%, meaning that the model is not just better, but it's more stable. And the key Earth observation predictor was NDVI minimum, hence the vegetation stress indicator capturing the worst month of the season. And if you look at the FICO band calibration, farmers in the exceptional band predicted by the model had a 0% default rate in the record that we had from the Mkulima score. Farmers in the poor band, so predicted to be in the poor band, actually had 83% of default. So clean monotonic discrimination from a satellite signal. Now, these are preliminary results because 95 records is not a large sample, but the direction is clear and it's consistent. Kenya is the proof of concept. The next phase is scaling. So in Zimbabwe, we will leverage FAO's existing geospatial farmer registration system and the Estela program, connecting credit scoring to infrastructure that is already operational. In Brazil, we will test the model in a more formalized smallholder context. And in China, we are in dialogue with CBAS and National Agricultural Finance partners for large sample validation. So the timeline is 2025 has been the pilot with 95 records. In 2026, we are targeting scaling up beyond 300 records per country. By 2027, the goal is integration, so an open source methodology that financial regulation and lenders can adopt globally. So crop PI and GeoCredit together teach us three things that should guide the post-2025 Geo work program. So first of all, data must become decision. The pixel only matters if it's linked to a subsidy, an early warning, or a lending decision. So invest in decision pathways, not just the data pipeline. Secondly, innovation must become institutions. Measure success by embedded adoption in national statistical systems, credit scoring systems, or financial system, rather than by research publications only. And silos must become integration. So the ultimate goal is a farmer who
Okay, thanks for Lorenzo. Give him the time. Yes, I think this is a great presentation. I think this is a really beyond. For me, this is a kind of one of a very innovative approach, not just only for the EO as a monitoring system, but also connecting to the next, decision-making process including about the crediting. Crediting is one of the big potential perspective, and the FAO said about this. FAO trying to this innovation. So this is one of the UN organizations trying to do this. So let's. It is pity just that he cannot be there, but I think maybe insightful, and then you have you can discuss at the panel discussion as well. So I like to. Next, let's move on to the next one, Dr. Ray Huang, and then you have a more focusing on the AI and the big data. So
yeah, okay, thank you, Chair. And we know that 2030 is approaching, and we are my topic is about big data and AI-based SDG indicator system, and we try to build a new SDG framework using big data and AI, and we try to play a more important role for Earth observation and AI to play more important roles here. And the background, as we know that the global SDG is far off track, and only about 35% of indicators are on track. And the data gap is still a huge challenge. Only about 50% of targets have trained data during the last 5 years. So the problem is more serious in low income and global south countries. For example, for the least income countries and in the least income countries, and they have the least SDG score. And for the small island countries, small island developing countries, and Middle East and North Africa countries, they make the slowest progress during the past 10 years. And besides, the low-income countries lack sufficient ability to obtain SDG countries. We know that they need more data, but they have lower ability to obtain SDG data. So this is the background of the data. And in China, there is another problem that using big data and statistics, we have evaluated about more than 200 SDG indicators last year. However, there is another knowledge gap, because sometimes the government may ask, what should we do next? How to promote the SDG indicators in a whole? But at present, we can't give a systematical answer, because there is the drivers of the different kinds of indicators and too many indicators, and we cannot provide systematical paths in the future. So that's a problem in China. And for the global scale, we tried to use big data to evaluate the global progress using big data and AI. However, it's very, very difficult. Last year, we released a report that using big data and AI to evaluate the progress using big data, we found that only about 15 indicators can be evaluated. And the progress, so there is a great lack of global, consistent, and high-resolution data. Okay, this is the problem of different countries and different cases. So based on the problems, we need a new SDG indicator systems. For this new system, we can use the big data to cover all of the person and all the pixels in the world. And the data should be updated frequently, maybe annually or even monthly. And we should know clearly the interconnection and influential factors of each indicators, rather than a progress of a single indicator. And in the future, we want to know the future of each indicators. So we should enhance the ability to predict the indicators and then make decisions for decision support for the government. And finally, we should build a strong digital infrastructure to support for each country, and each person can access these data. So based on this reason, we try to build a new big data-based indicator system. and a new digital infrastructures. Then finally, we call it an alive SD system. For the big data indicators, we at present we divided it into 6 areas, including the energy, urban, and agriculture, which are more related to human activity and human life, and also water, climate change, and ecology, which is more related to nature environment. Based on these 6 areas, we plan to define about 100 indicators. Then about the digital infrastructure, it includes the satellite and cloud computing and AI. These infrastructure are aimed to make more frequent update of the data and higher resolution, higher accuracy, and automatic prediction. Then finally, we try to fulfill the SDG goals, means leave no one behind and leave no pixel behind. I will introduce some progress of recent work. And last year, our institute, CBARS, have launched an global international cooperation program named the DSP. It has been launched and endorsed by UNESCO last year. And for the satellite, we have launched SESat-1 3 years ago, and the data was shared more than 100 countries. In the next years, we will build the global SDG satellite alliance. It includes the virtual SDG satellite alliance, and we will launch about 3 new satellites about different SDG goals. For the digital infrastructure, we will update the cloud computing into the cloud computing and AI together, and enhance the ability to the scenario simulation and decision support. Here I will give some examples of how to define the SDG indicators based on big data. For example, in the old systems, about 13 SDG indicators 13.1.1, it's only related to the number of deaths in disasters. However, in the new system, we give more details of the disasters. We classify the disaster into drought, for example, for drought, for flood, for heat waves, and this is give more refined information. For some other indicators, for example, SDG indicator 1.1.2, we continue the existing SDG indicators. And for SDG indicators 13.2.2 about the greenhouse gas emission, we newly established a new indicator about the progress of carbon neutrality about the world. It can be evaluated using Earth observation. So this is the example of the areas of climate change. And this is an example of the indicator about land degradation. In previous work, it is about one value for each country. But in the new framework, we can give more details of high resolution details of different pixels. And it's not about just the monitoring about the state of the indicator, but also give the drivers of the indicators and the reasons why it is like this, and give more ability to predicting to support the decision making. Okay, at last, this is and the program is at the very early stage, and it includes the new indicator system and a new digital infrastructure, and we will share more and public good, and we would like to invite all of you to join this program, And it's at the very beginning, and we like to invite all of you to join in this work. Okay, thank you.
Thank you very much for your really great presentation. And then this, even you are proposing a new framework as in the stages. One question from the audience. Any? Okay. Okay. Let's have a more discussion in the panel. And then I think we have two more presentations. Plus, after that, we have a panel discussion. So maybe we can I ask to allow about maybe 10 or 15 minutes to extend our session. It's okay. Okay. Right. Okay, let's go to the next one. Is Monica and Manuela, you are from the European Commission, no, not the Commission, ask, and also the CMCC. So you have a floor.
Yeah, thank you, Sama, for the introduction. And the fact that Manuela and myself are coming here is just to show the teamwork. Different stakeholders are providing different capacities. And when we talk about the Sustainable Development Agenda, this is a realization. One actor is not able to cope with all the complexity that the SDGs is bringing. And Rajula was addressing that already before. So research institutes like the European Mediterranean Climate Center in the CMCC Foundation, the European Association of Remote Sensing Companies, bringing the operational side, because the companies are more are in direction of this line of the last mile that had been discussed, but others that the research institutes that were involved in these discussions. We wanted to come here in a tandem approach just to show the dynamism of these discussions on the SDG. It's an alive discussion. It is a multilateral discussion, but it's a voluntary reporting. And probably with this voluntary reporting, maybe is why we are lacking back a little bit behind. And this is bring maybe the connection that we will make later, that the Sustainable Development Agenda needs to be also interconnected with other agendas, the skills, the Pact for Skills, their digital agenda that they are discussing also at the UN level in New York, another agenda. So it is the SDGs, the Sustainable Development Agenda, but how that are coping with another agendas. So at the European level, we have been trying to put forward an enhancement of the Copernicus program, but not only it's about satellite-derived data, but other data sets that the different organizations are bringing together. And with that, we wanted to have this scientific approach, which will give validation, the technical part that will be maybe the platform and the tools, and then the personalization, and obviously with the framework of the co-design approach. And when I say that about the co-design approach is that the different stakeholders need to be together to discuss. So we stop it a little bit at the beginning thinking, okay, we need to understand the needs. There was the needs that Sanjula expressed at the very global level, but at the localization level, we wanted also to make a step further. We go from the local, the regional, and also the global. So we wanted to do this bottom-up approach. Data fragmentation, so obviously there is risk related these interoperability issues to the different platforms, the institutional inertia. We know that the Sustainable Development Agenda is somehow, the mandates for that is the statistical community. The statistical community have a different modus operandi, and I would say that the geospatial community. So there is a sign of understanding between the institutional dimension, but also the inertia. So for adopting new methodologies, they need to understand about that data sets and how these data sets should be integrated. And maybe there are topics here about validation, uncertainty of the data sets, etc. So we need to have this information on go for moving a step forward with this institutional dimension. The local capacity gaps, when this is about the capacity building. I mean, the NSOs, National Statistical Officers or institutes, they are not working only with the full set of indicators. They have the mandate to report on some of those, but others are coming from other organizations. So there is this capacity gap that maybe between the Environmental Protection Agency in Ireland could transfer this information to the custodian agency and the custodian, the National Statistical technical office and then go out from the voluntary national reporting. So the complex exists and the expertise is needed. Then it's about the validation and common metadata. So this is fundamental for building trust. It's not only trust on the stakeholder that they're producing the data, it's in the methodology, in all the pathway, and then it's the long-term sustainability. So with this understanding of these needs, we came into the focus. So what we need to do with the different stakeholders that I mentioned before, we thought that a visualization or maybe easily interpretation for this new community is something that is needed. So let's go for that visualization easy pathway. The replication workflow. I mentioned that we started with pilots in different regions in Europe with different realities, focus on the sustainable goals, but they're looking more in the environmental dimension. Try to see from the local part, we will go from the national part and then scalable to Europe. When we have the dimension about Europe, Eurostat has a set of indicators that they are not matching one-to-one with the UN SDGs indicators. So there is another complexity between indicators at the UN level and indicators for Europe that are driven by Eurostat. So you need to connect that set of information. Then it's about the timeliness or the special rating. So there is a potential evolving of this set of indicators, and through the technology we could move above. And then it's about the quality assurance. We wanted to be sure that the data that was ingested has all this uncertainty traceability. And now Manuela will explain a little bit about the activity.
Sorry, I went to... Okay. This is the methodology of the SDGs project, and it's as already mentioned by Monica, it's based on 3 main pillars. One, it's science-based development because we want to build a robust SDGI. So we have the definition of SDGI, but for this project, we have to address Eurostat SDG. So we have to be sure that we can fit this the exact definition, but we want also to be to answer the policy need and the need of national statistic offices and the reporting agency on SDG. So we really want to do something that it's related to user needs, as well explained by Monica. We want to build up a framework where we to give trust information, and this indicator should be demonstrated on pilots area. So the concept of the project was to bring together different actors, scientists, stakeholder community, and industry expert in Earth observation. And we base mainly on most use services from Copernicus family of products, because first it was a European Horizon project, and we aim to boost the use of the information that we have from different services like Copernicus services, emergency and marine services. And we use, of course, we integrated this information with all other in situ information that are needed to describe well what happened at the local level and for society and for economy as well. And we address few of the existing indicators, and we focus really on the 3 targets. So we focus on the climate action, on the life on below water and life on land, and we just focus on 7 indicators. So we selected 3 indicators from climate action. One, it was related to the GHG emissions from land use and cover sector and forestry sector. And another one was on the deviation, temperature deviation from cities, from urban, and one it was on the climate impact on human population. And we had for the life below water 2 pilots on eutrophication and acidification of North Sea. And finally, we touch the more standard indicator for life on land, so the change in the forest area, and the last one on soil erosion. So, and since these are the area where we tested this indicator, and we tested this indicator in this area because we were sure that we have local information and good connection with stakeholders, and they were engaged directly in the development of this service, and we applied a very good agile methodology that is typically used for technological development, but we adapt this agile methodology for the development of the service with stakeholders. So we get them engaged on the development of the service and the indicator since the beginning. And also we ask them data for validation, because another important part is the validation, so to get to give trusted information and data. So just maybe if you want to say something more about the co-design.
The co-design approach has been as a typical one, but we have this agile approach. So any user requirement was embedded into the discussions. But the comment here is about the policy integration, and that was crucial to get them on board, and also to think that maybe the different organizations, different authorities that could be there, like the Carabinieri in the forest protector bodies, they will take it on board, this information, to be able to report later on through the local authorities about how much greenhouse gas emissions for forest fires were implemented. So the policy integration was crucial from the very beginning. Just very quick on the how we then, or with all this knowledge, we put it into a platform. So we have this. I don't know if it's running, but okay. Well, there is the, you will see an animation, but otherwise you can go through the website, that you have this like a kind of back end and then front end. So there will be expertise that they would like to test their own data sets. So you will be able to go through the Python approach and then investigate with your own data. So that will give the opportunity to be the service scalable in other areas. So you take the different examples and you could run around these new data sets, the geolocation, and they will give you results. That was very valid because we, in the validation process, we put these webinars on board, and we were having people from the different regions in Europe testing this information through the local end. Manuela will go from the front end now.
Yes, this is another video, and this is the explanation, an example of the front end for the indicator on GHG emission from forest fires. And this is the front end where you can select the year for the emissions and the region and the specific events. You can run it, and you can get a map of all fires in that region, and you can get also information about which is the gases emitted for these fires. And we have CO2, methane, and other emission, and we have also the emission for each plant functional type of each type of forest that are burning this fire. And you can download the data using different methods. This is a standard CSV Excel file where you can have information about all fires, events, and with all gas species that with the concentration. But you can export also maps that are easily uploaded in GIS software, and so you can download the map shape files of the burn area with all attached information about the emissions for the specific fire. You can download and upload in your website. And this tool, it's mature enough because it can run at national level, so you can get all this information for whole Italy. And again, interpolate also other information. It's not only about burn area and emission from that area, but you can have also information about which species are much more affected by the fires and which is the area of forest lost by these fires. So that's and this is the methodology standard and for all the tool we developed. And so the main conclusion are that we provide a very easy, intuitive and robust mapping of interesting SDGs, and the design, it's a replicable, scalable workflow. And we increase, of course, temporal resolution because we need the timeless reporting, and mainly during we need interannual variability as well. And we improve spatial scale using our resolution data when possible. And of course, we always try to enhance the accuracy of the methodology because we really take care about the accuracy on the technology, on the data workflow and methodology, but of course in the validation because we put a lot of efforts on that as well. Thank you very much for listening.
Thank you very much, Monica and Manuela. You are really comprehensive tool has already been developed about this. So this is really excellent. You have done quite a lot. So because running over time, we really like to extend our session, maybe 10 or 20 minutes. Sorry about that, lunchtime. However, we still have one more presentation. Last but not least, I'd like to introduce Genki Terauchi from Japan. And so you have a floor.
Thank you. I hope you're not hungry. I try to be quick. Okay. Okay, my talk is about SDG 14, and I will be introducing my project working with JAXA. This map shows the program that I work for. We are the part of UNEP Regional C program and Northwest Pacific Action Plan and the program that China, Japan, Korea, and Russia joins. And we have more than 20 years of history there. And we are the ones producing satellite-derived chlorophyll A data set because it's important indicator for coastal eutrophication, because one of the response to eutrophication is excessive growth of phytoplanktons, and that is visible from the satellite sensors. Today, we have so many satellite sensors. And in this platform we developed, we have been using NASA SeaWiFS, NASA MODIS Aqua, which is in operation today, has more than 20 years historical data. And we have been using ESAR Ocean Color dataset, and of course, JAXA dataset. So even like expert like myself, sometimes get confused. There are so many datasets available today, but policymakers do not really need to know the difference between these different sensors. So what we are trying to do is to blend all this data set to make one-time lease that is necessary for our assessment of coastal eutrophication. In working with UNEP, we have contributed our work, and in this manual published in 2021, there are chapters to describe about how we use this chlorophyll concentrations. And there are two different levels that the chlorophyll concentrations are believed to be useful. And the level one is like a global level. And because we work for regional seas, we work specifically on level 2. And there is another chlorophyll concentration value in there. Okay. So we started our work on a small scale, from local scale, then to a regional scale, and then somehow end up doing on a global scale assessment. This is our history in NOPAP. We started developing our own database to have time series of satellite-derived chlorophyll. And then it took some years to develop the methodology for assessment and came up with these 6 colors you see on the screen. And I will show you how it works. Okay. So everything starts from daily or pulse observations. Today we have every day based on a daily basis observations. But at the end, like policymakers like to know what's going on in our ocean, right? So the logic here start with daily composite and then monthly composite. Once the monthly composite is ready, we ingest those data sets into Google Earth Engine. We partner with Google. And then once the data is ingested, we calculate the recent 3 years mean of the satellite data, satellite-derived chlorophyll level. And then at the same time, we calculate the interannual trend of each pixel locations. One location you see decreasing trend of satellite chlorophyll, another location you might see increasing, and sometimes there are no trend at all. So by combining the level of chlorophyll and the interannual trend of each locations, you can make one map. And this is our system. And now I want to talk about why we need JAXA SGLI. Using global data sets available today, often you get 4 kilometers or 9 kilometers very sparse spatial resolution data set. But eutrophication occurs in the coastal zones most of the time, so you need higher resolution satellite data set. And with JAXA Ocean Color data set, you can get 250 meter spatial resolution in coastal regions. And this is an example in the southern regions of Japan. So now we work with Ministry of Environment, and we are trying to tell the ministry that, okay, let's try to make SGLI data set very useful to monitor our waters. And that's the light purple you see on this map is the territorial sea that's claimed by the Japanese government. And we are trying to monitor the ratio of these 6 colors and trying to produce this map on an every year basis. So in this particular case, well, you need to get close to the map to find out this red color pixel, which is the red means the chlorophyll is higher than 5 milligram per cubic meters, and it's been increasing. So we are taking that red color pixel ratio against the regions of interest. In this case is the Japan Territorial Sea, and reporting the numbers to our government. That was a case of Japan, but we work in a global scale with partnership. We work with Google. We work with UNEP, World Conservation Monitoring Center in Cambridge, and we work with Latin American scientists who really cares about the coastal eutrophication phenomena. And today I would like to announce a new platform as a result of working with UNEP WCMC. This data set will be made ready within the next 2 days. So you will see coastal eutrophication potential data layer at the UNBL. At this moment, we are ingesting and we are using ESAR climate change initiative data set, which is 1 kilometer and 4 kilometers. But this year we have a plan to make JAXA 250 data set available on the global scale. Thank you very much for your attention.
Thank you very much, Genki-san. So much a great, really, very sophisticated presentation in terms of the eutrophication, which is our cooperation in Japan. So let's move on directly to the panel discussion because we are running over time. So I'd like to switch over to my fellow co-chairs. So yeah, please.
Okay, thank you. Hello, I'm Li Junzhou from CBAS.
So the time is very limited, so I will be quick for this part. Just now, our speaker have present the need and how the EO and AI technique can empower the monitoring of SDGs. And now, as we are have passed the 10 years of SDG, we only have 18% SDG, which is on track, and 50% of the data is lack of indicators is lack of time series data. So, except for thinking how to use the EO and AI technique to monitoring the SDGs, I think we should also rethink the SDG indicator system itself. If it is suitable for us to move forward, and I would like to summarize the 4 questions into 2. So first is based on your experience, have you come across some problems when you use the EO or AI technique to monitor SDGs, and what do you think? What kind of improvement that we can promote to the SDG systems? And second is that is more maybe we can bring the science out of the ivory tower. That is how the private and public partnerships can contribute to the implementation of the SDGs, and how could we raise fundings for our activities. So maybe we will go Patricia first. Yeah.
Yes, thank you. I mean, it's big questions there. Big questions there, but I think we have a lot of great ideas on this panel. And I think in terms of, well, the first one in kind of examples of using EO and AI, I think I gave a number of those. One of the areas that we are focusing on now is creating these AI models, pre-trained AI models. I think we have put out over 100 of those now based on kind of training models to find specific things, and many that address the SDGs, and those we make openly available so people can kind of jumpstart to get further faster. And I think having those pre-trained models, more of this data open and available, and then marrying that up with those training materials we talked about, hopefully we can amplify the effort and everybody moves further faster, whether it's using AI to identify the solar potential, or look at crop stress, to look at some of the proximity issues of rural development and access to roads, things like that. They're very well suited for those large models. In terms of taking it out of the ivory tower, I'm totally with you on that. And something that I think we've seen examples here on the panel, and we too, trying to create those executive tools, make those the data and the outcomes, the learning, more understandable to the common people and not just the scientists, and do it in that. And I think what we bring from the EO GIS world is that the value of a map, and being able to see the change, the relationships, and help people relate to what's on the ground there. I think the tools are there to do it. I think we've seen some more examples there, and certainly we're putting more and more out and working through the EO for SDG working group to share those.
Yeah.
Yep. And I apologize, I am late for my next thing, so I might slip out.
Okay, please. Thank you for your share insights. Yeah. And then maybe Ranjula, you can share your insights on the questions.
Thank you. I'll just keep it brief. I think it's important to integrate the methods of AI, whether they are for monitoring, data collection, or analytical purposes, with the other traditional ways of data collection, and also non-traditional new ways of data collection. And some of these data collections are mandated to the National Statistical Organization. So how do you integrate those data? And the reason why the integration is very important is because we can't just look at one indicator, just environmental indicators of some kinds and then use them. The data frequency, the data resolution, granularity is different. So we need to integrate it with other data systems to understand the interlinkages within the different indicators for for gauging the progress and also understanding how policies can be designed for the progress of the system. I don't think it's just one thing we need to. So I'll stop there. Thanks.
Yeah, there is no one single data can solve all the problems. So we need the integration. It's very important. So, Dr. Huang, do you have any?
Okay, I will respond shortly. I think the largest challenge at present is that when we use different data source, different satellite or different data source and different AI models, it's possible that we get different answers or different results. So I think most urgent work is to how to reach an agreement globally to choose the best, maybe the best or acceptable data or data source, data or AI models to make the global standard and global agreement for each indicator. I think, yeah, I hope it is possible.
Okay, yeah, the standard of the methodologies is very important. That make us can compare different results, different yeah, something that can draw a conclusion. Yeah. Okay.
Yeah. Well, we have been discussing about that integration, but for me, I will keep the question about the public-private.
Yeah. I think you are good.
There, so we'll pick the other one, which is complex, by the way, because here we need to see which is the stakeholders typology here. We're thinking that maybe the SDGs framework could sit together with the ESG framework. The ESG is environmental corporate responsibilities. And this is when you have the private sector on board. You have energy companies, insurance companies that they need to report their obligations. So somehow it's to matrix these frameworks with another existing frameworks that somehow maybe there are other type of regulation there. And in fact, in Europe, we have regulations related to corporate sustainability and they need to report. So we see that there will be the mobilization of the framework itself, but more importantly, also the financial system, and they will put the investment to mobilize this framework. So I think the partnership, I think is very feasible that you can partner public institutions and private institutions, thinking in maybe bridges, the other type of organization are bridges toward the communities, not that the government will fit already with the energy sector, but they are the EU community to could help the bridge. So I see this connection is quite needed. So that was my point.
So about the data integration, so it's in my point of view, it's very important also to see which is the level and for what we want to use artificial intelligence in the process, because we saw also in the plenary that there are very good examples of the use of artificial intelligence for change detection maps and for classification. That's very powerful things. But if we need to more complex processes that lead to the definition of SDGs like soil erosion, there we need more integration of different data and process. And sometimes this process are physical based. We can try to maybe cover or describe with artificial intelligence some part of the process, but maybe not the full process. So I see also there the good integration of Earth observation and artificial intelligence to have a new, like a forecast climate variable for rainfall erosivity or for fires spread or something like that. So I see really these two parts of the development, but of course we need really to clarify in the workflow, which is We use artificial intelligence for doing what? That's
Yeah, that's true. That we need to integrate the EO and AI together to implement the SDGs and also for different for private sector and the public sector, they have different roles in this process. Maybe the private sector, they will be more close to the users. They know what exactly we need to do. Then the combination should be accelerate the implementation of the SDGs. And then, Jenk, please.
Thank you. So my experience using AI, I believe it is very useful for validating the input data. Especially today, we have so many different sensors and intercalculation among different sensors. I think AI can play a big role here. At the same time, we have to be very careful. Like when we try to use AI for data interpretation, I think sometimes you get really wrong information, and this is not very useful sometimes. So, and that's where we need to work with local scientists through communities, because they are the ones who has the knowledge. And I think humans should play a big role here to interpolate the information we get from Earth observation data. Thank you.
Yeah. We cannot get the one solution for all, so it is very important to relate it to local people, the local experience in the estimation of the SDGs. Yeah. Okay. Yeah, I think it is time for lunch, and we really appreciate for the audience participant, and I will ask us all to appreciate our panelist speakers, yeah, with applause. Thank you. And do you have anything you want to add?
No, that's fine. Yes, thanks so much for participating. We're all hungry. And then I just want to know, because the EO SDG is still up and running. So we like to continue to discuss about the involvement of all the partnerships to further down what we have discussed in the future. So thank you very much. Yeah. Can you take a photo? You have a copy? Yeah, please. So at the EO SDGs task, we sometimes discuss about how CMS can
Yeah, sure.
So let's discuss.
Yeah, we have a lot of work actually, based on the
That's great. So
Yeah.
yeah, looking for the full chair of the
Oh.
university.
Oh.
Yeah, sounds good.
Yes, yeah. I really appreciate if they have a chance that we can work together. Huh? Yeah, discuss. Yeah.
That's great.
Yeah.
I know we can meet there.
Fantastic.
Collaborating and yeah, so I have a question on you left the France fiscal and I'd like to when we appointed so is there anything that I'd like to integrate your work online? So if you could let me know which information that you'd like to start thank you so much. Yeah, so I'll get in touch with you what specifically you want me to do. Fantastic. Congratulations. It was really well done. old source, I think we have monitoring things that are. It's not my first point of evaluation, so I'm very data. Like how do we know that they're happening directly and it's not saying that they're so it is a part of the national statistics and organization, but they have to map this on the outside. So why should we just map for them? Because we should empower them to they have the ones like the rest of the station, they have statistician part that's so they have like the things transition with our organizations. They usually obviously are working developing and incorporating with these aspects. That's the really big piece because sometimes we talk about the they have initiatives so whatever they're doing that's what which will not be the case let's say your ESGs. They don't need it for it's yeah. That's what I thought like the question that you asked was so important. We already still discussing this. Yes, Plus, I have access to like now I know there's such resolution data for eutrophication. I have like the professor in my department on eutrophication in the Baltic Sea, and I can point to it. Like, look at that data. We can use that.
Actually, our institute we also
amazing.
produce a lot of data, and I think a lot of people are working on this field. It's so
yeah. I think you should have that. Why did you send it? It was in space.
Oh, it's okay because I think maybe it's too tight for you to.
No, it wasn't. You could have easily done. Because everybody was there.
Oh, yeah. I can't at last. Yeah. Let's wait.
Yeah. Okay.
This is the lunch. Lunch. I have to go with you. Yeah. Let's go.
We want to write. I was still full.
I will go with you.
Oh yeah, I did.
Yeah. Just pay for it.
They don't run out.
They didn't scan this one.
Yeah.
Yesterday.
I guess it means the hamburger. Yeah.
This one. Oh, it's hot.
You deserve just tea.
I just no, there's not coffee. This is hot meal.
Hot meal. Yeah.
Okay.
Okay, let's go. Oh, hot meal.
But the other days I was not there, so I said no.
I'm not sure whether I will have much. I'm not hungry at all. I just in the morning I wake up at 3 o'clock.
Oh, because of the jet lag.
Yeah, I'll be let's say for there.
Yeah. It's always difficult to travel. Yes.
The idea is to say this is coming from skills just before show development. Which let's start essentially one is into data set. There is one service here, which is comparing display. Then I put on this is in fact comparing the service. You see, we have comparing display, comparing design, and master CM. Okay? Yeah, then we can do it. It's better to you see secrets, and we have which is a service. Because they have this implemented a specific features for see it's possible to install and have instructions for each data set. We have a show you in a nutshell.
Inside. Okay, the standards.
Yeah. Singular university, university in China. Yeah, people see this is not made by everything. Just books. As though I want just one word issues. Simple. For example, here, I could just this is that's in fact, yeah, I know. So far, but why is not?
Yeah. I think I want to say just something. Can we these things more carefully? Right? That's the change.
Yes, this is just a just copy and paste. Here I will keep the check from here. Is the only one that will check the rest.
Yes.
Yeah. And
Francis.
yes, here. You see, always when we have moved from text or from breakpoint to page, then we have some special some. Then the rest will just okay. this is not really slide, it's like that, but it's like this. But see, GEO shares like vision. Supposed to go with the like then this was your this is great. So yeah, all those we mentioned shows who can contribute there, contribute to the resources, control which contributes for restricted to raise the organized. So this is all of this. Yes. Yes. We are learning to I think it is disseminating people knowledge is the way to spend. We have a convention. Knowledge preservation. This is about preservation. Culture of peace, open and accessible. Church preservation fine. You don't need to say that. That's because it's a yeah. So the friends.
We don't know. We don't. Actually, since it's.
Yeah, I would hint you one below that.
Okay, I can send a message in the folder about actually access the folders. Okay, I can send you somebody the categories. Okay, thank you. Yeah. I think
I can send you the because I was specifically.
Yeah, please.
Good to see you. You want me to sit here as a moderator, or should I sit in the room?
Yes.
It's great. Yeah, that's great. I don't think so. Maybe Diana can help. She'll come. Yeah, she'll come. Yes, she'll come. Trying to see what we bring. So just keep your okay, yeah. Sorry, this is just okay, so then okay. No, thank you. No, wait.
Good. That's a good start. Well, good afternoon. Hope everybody had a good lunch. Did everybody have a good lunch? I'm looking for nods, happiness, smiles. We're going to start here in a few minutes. So I want to give you a 2-minute warning, as we say. So buckle up. This can be one of those kind of sessions, I guess. Friends and relatives, ladies and gentlemen, we're going to begin. Let me begin by welcoming you in my language and in my culture. We say how inakia pi chante washte na pe chizapalo le ampetu ki lila washte wachi akapalo James Rattling-Leaf imachi apina sichango lakota oyate hemataha. I greet you this afternoon as friends and relatives. From my heart with a handshake, and I'm known as James Rattling-Leaf. I'm from the Lakota Nation called the Sichango Lakota Oyate, or the Lakota people in the United States. And it's my great pleasure to serve as a moderator for this session today and welcome you to it. And we have some distinguished panelists and friends and colleagues here with me here today to bring a good session. I believe that's important for the work that GEO has embarked on, but also just as importantly is really bringing an Indigenous perspective to this work at GEO in this time in our history. So let me begin with my first slide. So I titled this slide Buffalo Restoration, Relational Values and Indigenous Governance. So for me and my culture, we believe that the work that we do going now and to the future, but also remembering the past, is to establish relationships with the natural environment or with the environment. And for us as Lakota people and many other tribal nations or indigenous people around the world have these relationships in place. And I think it's really important for us to begin to think about how we do this work with indigenous people and how we learn from one another in terms of this opportunity. So let me begin by a picture of a tatanka or a buffalo. You know, we see tatanka or buffalo as a relative. When we begin to approach and think about how we work and how we think about the environment, how we think about the world, how we think about change, and how we even think about data and what data can do in terms of advancing our future as Indigenous people. We say the buffalo is a teacher. And I think what's needed, in my view, in the world today is education and awareness about not only who we are, but also our environment. And there's no better way, in my view, of utilizing the buffalo or tatanka as our teacher, and to think about that in terms of what must be known going forward. The tatanka brings us together. The tatanka is a relative. We say it's a relative, meaning that we are in relationship with it. If you know the history of the tatanka in America, it was almost exterminated. But through great courage and great leadership, it was brought back. And so today we find ourselves at a very important time in terms of how we bring back the buffalo. In my comments yesterday, I talked about this concept called ROAM, R-O-A-M, restoring our ancestral megafauna. So there's a movement, a global movement, I believe, that's happening. Maybe it's in your country as well, to bring back these species that have significance, not only to the land, but also to the people. So in my world, there's some place called Standing Rock. In 2017, sort of Standing Rock shook the world when we had something called the Coal Access Pipeline. There was an environmental threat to our land and our water and our future. And I forget how many nations came, but there was over 300 or more indigenous nations came to Standing Rock in South Dakota in America to stand with us, to protect our water and to come forward with prayer and ceremony to address this tremendous threat to our people and to our environment. So that, to me, in my view, that it made me realize that there are these networks in place that indigenous people have. And when something like that happens, it brought people together and to say stand together. And it was a tremendous event because if you saw it, there was these flags, all these nations brought their flags, and there was a line of flags along this area and representing their nations, representing their sovereignty, representing their culture. It was a tremendous event. And so what it did was it made us realize that we can come together despite our differences, despite our cultures, even despite our language barriers here. I come here to Geneva for the first time, and I don't know French. I don't know Swiss. But at DAPL, somehow those language barriers were overcome. And I think those are things that we can learn from going forward here at GEO. So when we think about this work, it's important that we understand again that what this return means. It's not just the physical nature of a buffalo back on the land, but what it symbolizes. In my work, in our work, we call it's sustainability. It's sustainability from the view of our cultures, our land, our ecosystems, our biodiversity, and our spirituality. So we need to think about that in terms of when we begin to talk about the role of science, the role of data collection, and this term called biodiversity indicators. We talk about this need for more of a relational understanding of how we do this work rather than just numbers and things like that, which are important. But I think for working with indigenous people, we need to think deeply about this concept of relationship. How do we work with that? How do we work with our cultures in terms of understanding indicators and how we measure, how we think about, and how we make decisions? We talked about governance being an important term to this work. There's nothing more important to indigenous people than our sovereignty and how we govern ourselves and how we govern ourselves for the future, and then how we govern and how we share and work across cultures and across nation states. It's very important. So these images again remind you again about indigenous people and how we do this work, how we come together, how we make decisions, but also how we work with new technologies, how we work with geodata. And I think those are the opportunities that we've been advocating as a Geo-Indigenous Alliance. We started 7 years ago in Canberra, Australia, where there are a small group of us gathered in a small room. We started talking to each other about what can we do for indigenous people now and in the future? How can we be strong advocates for indigenous people? How can we bring ourselves, our full selves, to these kind of meetings so we can represent ourselves and our people well, so that you as a community can better understand us, who can work more effectively with us, and also create opportunities to do that work together. So this is one of our co-founders, Titus Latambo. He's been one of our leaders for 7+ years, and he represents, again, a tribe, a community in Africa who are advancing and using geotechnology data science to help answer questions in their community, to help solve problems in their community, but also create opportunities for them. So we appreciate and thank Titus and folks like him who are doing the work day in and day out. They may not have an opportunity to come to Geneva with us here this week, but he's in our thoughts and prayers today as he deals with things like drought. I was reminded again about the seriousness of issues our indigenous people face, and the question about equity and about justice and about things like that. What's our responsibility to Titus and people like Titus out there who have these tremendous needs? It should confront us. Those who have the opportunity that could maybe support him. So I just want to say that to Titus. He may be listening online here today, but I just want to think about him today and think about his people and other people like him who are facing these severe environmental challenges. Also, our friend down in Amazon. This is Mario. I have a hard time with his name, but his name is Mario, and he's Shuar, his people. And the Geo-Indigenous Alliance have been working for 7 years to bring together our cultures, to come up with a common vision that we can apply geoscience data technology to the work that they do. In their case, they're protecting. They're protectors. They see these threats in their community. they see these things that they have to deal with every day in terms of development of their lands and their cultures, and maybe they call it expectation of their cultures and their lands. And so they're looking and continuing to strive to find ways to utilize geoscience, data, and technology. That's Mario, and also thinking about him today as well. So as I wrap up my remarks, I want us again to think about these things that I just shared, but also again hear perspectives from my panelists here to bring what they think is important as well from their view. And we welcome them and we thank them for their efforts to bring this perspective to you, and also this perspective to GEO Digital Alliance. So with that, I want to ask Gwen Bridge, who's here to my left here. Gwen and I have known each other for the past 7 years. She is from Satellite Cree in Canada, brings over 25 years of work of Indigenous people, Indigenous knowledge, conservation, leadership, and many good things. So with that, Gwen, welcome, and the floor is yours.
Tanse Nia Gwen Bridge Nisigasun Nehewa Kasqueo. I'm Gwen Bridge from Saddle Lake Cree Nation in Alberta. That's in northern Alberta, which is, I don't know, 55 degrees north in the interior at the northern fringe of the Great Plains. And I didn't spend all my time there because I'm also half English, so happy to be back over here where I've spent quite a lot of time in England and other places. So thank you, GEO, for having me. Thank you, GEO Indigenous Alliance, for inviting me to be part of this panel. It's a bit of an interesting moment. When James mentioned his involvement in GEO 7 years ago, that was really the first time that I got to know him. And I was pretty impressed that James could be part of something like GEO Indigenous Alliance and GEO and doing that work and giving the United States intervention there at the Ministerial Summit in Australia. So happy to be here and see this movement growing and the support that you've been able to consolidate and continue throughout these years. So really proud to be here with you guys on this stage. I'm going to talk a little bit about sort of these perspectives from a community member perspective and a community supporter perspective, and some of the understandings that have emerged from my now few decades of work, both as an Indigenous person, but also as a person who's working with Indigenous communities really to support their aspirations of all kinds, but oftentimes in biodiversity protection and conservation and better natural resource management. So that's what I'll do here once I figure out how to advance the slides. So, whoops. Yeah, so I just want to say this is like, whoops. This talk is called Biodiversity Means, Measures, and Decision Making. So James mentioned decision making. I want to talk a little bit about what are we trying to achieve? What are the means to achieve the things we want to achieve in the world? Collectively, us here presumably have some commonalities in the ideas that the ideas we're trying to preserve or to advance using Earth observation data. So what are those things? What are we trying to achieve? How do we achieve those things? What do we measure to achieve those things? And then how is that utilized in decision making? So really this idea about connecting Earth observation and Indigenous decision making in a short, however few minutes I have. So this fundamental question that this is a session on biodiversity, but we're really wondering if we're observing the Earth, and all of us do that as humans, whatever culture we're from, we're looking at the Earth, we're taking that data, we're doing analytics on that information, we're drawing conclusions, and we're making recommendations. And that's really important because at the recommendation stage is where Indigenous knowledge differs from Western science. And we'll get into that as we go along in terms of why that is. But really thinking about why monitor anything, but why monitor biodiversity in this particular case, right? We have this idea that we've heard a lot of planning sessions here, and that's really important. We're going to have to do disaster response and resilience and climate change and environmental disturbance mitigation. So we really want to say, okay, we definitely don't want things to get worse. Can we adapt? Can we really plan for mitigating some of these most negative impacts from the changing environment? There's a lot of Indigenous knowledge in this planning component that we don't have time to get into today, but suffice to say, one of my colleagues, Rob Edward, who's in Okanagan, said this is not our first rodeo in terms of climate change. What we understand from tribal nations in North America is that climate has changed a lot, and that tribal nations have knowledge, history, and understanding about how to move through those climate change periods. We're also looking at conservation. There's inherent value to biodiversity. It's important for food diversity and sovereignty and supply, medicines, ecological function, and literally our water and air. So we're really concerned about moving forward and advancing that. So we need to understand what we're looking at when we're thinking about, are we doing a good job? Then there's the cultural preservation, which is important human cultural continuity and knowledge. And I think this is really where this application of Indigenous knowledge in particular is vital for, yes, cultural preservation, but we know more and more from some of the other global conclusions is that Indigenous knowledge is critically important to the ability of us collectively to secure the world's future and the reduction of biodiversity loss. So the question here is when we're monitoring this stuff, when we're thinking about, okay, we're taking some observations, we'd like to do analytics on those observations, what creates the biodiversity? What creates ecosystem resiliency, the inherent characteristic of the Earth to maintain itself? Before we were here, perhaps, and perhaps after we're gone. But in sort of conservation and biodiversity thinking, what do you think creates that biodiversity, right? What creates biodiversity is the relationship of the Earth to itself, all the elements of the Earth to itself. We call that, as sort of conservation scientists, the ecology, right? Those relationships between all the things of the Earth create the things of the Earth. They create the biodiversity. What maintains and facilitates the exercise of those relationships in a way which perpetuates biodiversity is the application of Indigenous knowledge specifically designed to perpetuate those relationships. So that's really some of the thinking around what is Indigenous knowledge as it relates to biodiversity. So the reason that Indigenous knowledge is so important in that exercise of maintaining those systems is that those systems of understanding grew from place. They grew from an understanding of relationships which were designed to perpetuate themselves. And in that exercise of perpetuation included obligations to each other to perpetuate each other. So this understanding of the relationships between all the things of the Earth and humans is this notion of reciprocity. So it's a deeply interconnected, dynamic set of relationships which is designed to perpetuate itself. The perpetuation of that self, of those sets of relationships that are understood and applied by Indigenous communities is what we are now calling biodiversity. We measure that in Western sciences as numerical, as a set of numbers or number of diversity of species, number of species. And I do have, as means by way of introduction, a Master's of Science degree in forest hydrology. So I really got to understand a little bit the importance of measuring when we're trying to describe the ecological relationships in a way that we are, communicating amongst each other in the scientific community. So this set of information that we're trying to observe, understand, and facilitate, i.e. we want preservation of biodiversity on the Earth. These are grounded in knowledge, observations, right? So observations form the basis of knowledge, right? And that Indigenous knowledge is now, as we talk about the role of Indigenous, Geo-Indigenous Alliance within GEO, is this idea of understanding both the Indigenous knowledge from those decades of observation and the facilitation of relationships that result in biodiversity and geodata. Right? Our Earth observation data. How are we using those things? If we're thinking about knowledge acquisition as a process, why do we do that knowledge acquisition? What is the reason we're so curious about what we need to know, right? Well, I was, thinking a little bit about this, and it's like, what we're trying to do is solve some kind of problem or challenge, whether it's access to food or water. We were talking about some of the work happening with our colleagues in Kenya around we're trying to solve a problem. What do we need to observe and know and apply? We need to build a set of observational conclusions to address the problem. We need to prepare our communities for the implementation of that knowledge really strategically. We need to build accountability mechanisms for making sure that that knowledge is applied effectively And then we need to have the application of that knowledge directly through, in the case of Indigenous communities, community life. So people who are in community are working through this process of collecting knowledge for specific purposes, which is to maintain the relationships with the natural world so that they can live up to their obligations and everyone can live, right? And it's not for the observation's sake, or observing data for observations or data observation's sake, right? So when we're thinking about, well, how do those two things interplay? When we're thinking about the application of Indigenous knowledge to global planning, to localized planning, when we're thinking about the application of geospatial data or Earth observation data to this planning process, how do those two things work together? How do we understand the application of Indigenous knowledge, which often looks like this? People going out and picking blueberries, people performing ceremony on the land, water ceremonies, having a spiritual relationship to practice their obligations of reciprocity. People going out and picking berries or roots or these kinds of things, hunting, engaging in prayer and knowledge transmission activities. So the relevance of that type of information to our planning objectives is really important to consider. And how do we build planning around that type of work? We're often used to saying, okay, we have something that's going to happen as a result of our observations. We can predict and model these kinds of things. We need to develop the disaster mitigation plans or emergency management plans. And so the role of Indigenous knowledge in that planning is something that I'm questioning here at GEO. What does that mean? Does it have any relevance to the topic at hand, which is the acquisition of this information and the application of this information to solve problems, right? And so when we heard on the stages of various different sessions here, it's important for Indigenous knowledge. Really, the question we ask is like, well, how do, if we understand these different ways of knowing from those two perspectives, how do we integrate that? There is an important set of considerations, I think, around understanding that the knowledge that Indigenous peoples need to apply has really specific, yes, ecological considerations and important components there, which can feed into science and observation, but it contains an essence of the importance for decision making. Indigenous application of management needs to be supported by all those authorities in the area if it's going to be successfully resulting in biodiversity protection. A lot of the dialogue today is really, I think, confusing a little bit of the means to create the results that we want. So if we want biodiversity protection, we want to save the world, we want to stop these terrible things from happening that we're predicting, we're really thinking about what creates the positive outcome that we seek. What are those management interventions which create the positive outcome, i.e. preserved or increased biodiversity, preserved or increased water health or ecosystem services or ecosystem health, right? What is the means by which that happens? And now we were just discussing that sort of somewhat derided quote that came out of the World Bank work that 80% of the world's biodiversity is preserved by the 6% of Indigenous peoples. That is, generally true. There's been studies even in national parks, for example, those national parks perform less well in terms of metrics of ecosystem health than those areas managed by Indigenous peoples. And so what those conclusions tell us is that there's those important things around Indigenous knowledge. But what's most important about that is the directives that come out of the natural world themselves. That those things, those biodiversity, those relationships are providing directive for the behavior of humans. There's obligations for how we behave. Those directives are not esoteric. The directives that emerge from those natural worlds and those obligations, well, the epistemology of that knowledge is challenging. The outcomes and conclusions of that knowledge, if you follow that process of observation, analytics, conclusion, and recommendations, the recommendations are not hard to follow. So this becomes a challenge more so of law and policy versus data acquisition and data application and management planning. It becomes really understanding that those directives that emerge from those obligations are like law. Right? They need to be followed if we're going to support the means that creates the outcome that we want. So that's a challenge in westernized systems that we need to address. And so that's some of the work that I and others, including James, have been doing, particularly in the more North American context. And so following an understanding of how Indigenous peoples are sort of managing and thinking through the application of data. One of the components is how do we understand the consequence for the violation of the directives that emerge from those relationships, right? What are the consequences for the violation of that, right? Right now, it seems there's very few consequences for the violation of a law that would be emerging around, hey, maybe we shouldn't pollute all the water or put all the mines into, discharge contaminants into our water supply, which is literally what some of the Indigenous law says. We must maintain clean water, right? So when we don't do that, what is the consequences for that? And so what we're experiencing now collectively is a lived out consequence which was anticipated by Indigenous knowledge, which is, and some of my colleagues explain this brilliantly, the literal and figurative cultural death, right? And so what we're experiencing is this sort of existential crisis, which has been built on a set of consequences which resulted from the inability to adhere to and abide by Indigenous law, natural law, Cree law, Lakota law, these kinds of things. And so when we're thinking about how we hold ourselves accountable to a system which has demonstrated its consequences, which is grounded in directives that emerge directly from the natural world, how are we thinking about that? And then what role do we have in understanding the consequences of that through Earth observation data, which is really what we're working with now, is the consequences of the violation of those directives and obligations that emerge from the original relationships that defined Indigenous societies. Turn myself off, no. Just wrap up with some of this. I think on the session description, it talks about economics. And one of the things that we really wanted to think through is, yes, we understand that there's a lot of seeking of information about Indigenous knowledge, about ecological phenomena, this idea that there must be something really cool about the way that Indigenous people understand the natural world that creates the results they want, that we are hoping to achieve, like Indigenous peoples do biodiversity management better. So that's, and like I said, but that's not necessarily the case. It's really about those directives for how we behave with each other that are most important, that come out of that, the obligations to each other in terms of that relationship in the natural world, and understanding the consequences to that, and then abiding by that, and or aligning with that. What the IPBES panel, or the Intergovernmental Panel on Biodiversity and Ecosystem Services, said in December of 2024 is really we have to shift our allegiance to the systems that created these crises in the first place, which is sort of global capitalism and the economic system, and some governance regimes. And so the question then is that if we're looking to that, then there are important components of Indigenous knowledge about the directives about how we behave economically in relationship with each other that creates economic wealth, not only material wealth, but spiritual, relational wealth. And so some of those types of learnings are also to be applied in the economic sense and can answer the call of the IPBES Transformative Change Accord to reform global economic systems. Our intention with this conference was to inform that transformation with principles of Indigenous knowledge that have served in the past and can be at least informing the conversation around what a transformed economic system looks like. And this includes things like shift in the valuation of the means to results. How do we value the thing that creates the results that we want to see? And that is where I think I'll conclude this talk. Thank you.
Thank you, Gwen, and thank you for reminding us again about our responsibilities as human beings when it comes to working with each other, the land, and also our future. Our next speaker will be Diana Mastrazzi. Diana's been working in one of the, I'm going to call her a co-founder of the GEO Symposium Alliance. I met her, again, 7 years ago in Australia, and she's been with us ever since. leading us, co-leading us, walking behind us, and even directing me, which is very hard to do. But with that, please welcome Diana Mastrazzi.
So there is an old story. According to the laws of physics, the bumblebee should not be able to fly. Over time, scientists understood that the bumblebee was never defying physics. The early models were simply too limited to explain the complexity of its flight. The problem was never the bumblebee. The problem was the model. I think this is a useful place to begin after the case studies we have just heard from James and Gwen. Because in biodiversity monitoring and increasingly in AI, we often face a similar problem. When a model cannot see what communities know, the first question should not be whether the knowledge is valid. The first question should be whether the model is too narrow. Buffalo restoration is not only about the return of a species. Land stewardship is not only about managing territory. Indigenous economies are not only about livelihoods. These are relational systems. They connect land, animals, memory, responsibility, governance, and future generations. Earth's observation gave humanity a new vantage point. For the first time, we could see the planet from above, across borders, across seasons, across political boundaries, and across ecosystems. With radar, we can see through clouds. With time series imagery, we can see the pulse of vegetation, the movement of water, the scars of fire, and the stress signals of changing landscapes. That is extraordinary. But a new vantage point is not the same as a new worldview. If we use these technologies only to place the Earth into the same old categories, then we have improved our instruments without necessarily improving our understanding. And now with AI, biodiversity data can travel even further. A sound file, an image, a GPS point, or an animal movement track can become part of a data set, a model, a platform, a prediction, or a policy decision. As it travels, context can disappear, and also consent and authority. So the question we should be asking is not what AI can do with biodiversity data, it is what responsibility must travel with that data. And indigenous knowledge asks a more difficult question. Who has the authority to interpret what the change means? The same data can protect or expose. One of the clearest examples is animal data. Take elephant movement data. In one context, it can help communities reduce conflict, protect crops, understand migration routes, and avoid dangerous encounters. It can support both conservation and community safety. But at the same time, it can also create risk. If poorly governed, it can reveal where animals move, where they gather, where water resources are, or where conservation efforts are focused. In the wrong hands, the same information that protects an elephant can expose it. So the question is whether we should collect the data. The question is what responsibility comes with knowing. Animal data is not neutral information. It is connected to living beings, landscapes, community safety, conservation decision, and indigenous responsibility towards species and territory. And this is the reason why we developed the GEO Indigenous Alliance Ethical AI Biodiversity Toolkit with support from Jason Duffy from the Environment Climate Change Canada to ask these questions before data enters technical systems, before it is labeled, shared, modeled, scaled, or reused. Responsibility must travel with the data. Biodiversity data does not remain a simple record of the world. Once it enters AI systems, it can begin to shape decisions about the world. A sound recorded in a forest, a GPS point, or an animal movement track may begin as an observation, but later it can influence a model, a prediction, a conservation priority, or a policy action. This is why governance cannot sit at the end of the process. The toolkit follows the full life of the data before collection, during fieldwork, during analysis and AI development, when the data is shared and when it is reused. We have an online canvas that helps communities, researchers, institutions, and technology partners work through the core questions together. Who has the authority? What may travel? What needs protection? Who benefits? And who remains accountable over time? For us, the purpose is simple. When biodiversity becomes data, responsibility must not disappear. The toolkit helps us govern what happens when biodiversity data begins to move through technical systems. But there is a second question, and it comes even earlier. What do our biodiversity systems recognize as evidence in the first place? This is where the Geo-Indigenous Alliance relational values methodology comes in. Relational values are not soft values or additional context. They are the relationships through which biodiversity is sustained and understood between people, species, water, land, law, stewardship, memory, and future generations. They are difficult to quantify because they're place-based, governed, interpreted, and sometimes protected. You cannot turn responsibility to a river, the return of buffalo, or the loss of trust in a conservation process into a universal global score. But communities may still want these realities included because they explain what numbers alone cannot. They show whether a place is not only biologically present, but still cared for, governed, transmitted, and alive as a relationship. So our methodology asks, can we create a rigorous indigenous-led process for documenting this evidence without stripping it of meaning or authority? The methodology offers 10 pathways for documenting relational biodiversity evidence. They are not a checklist, and communities do not have to use all of them. They are entry points. A community might document whether seasonal practices are continuing, whether young people are still learning from their elders, whether protocols with researchers were respected, whether a river relationship has changed, or whether animal movement is signaling stress. For example, in the Samburu context, repeated elephant movement near water points might be selected as a community-defined signal of relational stress. The ecological data may show elephants appearing more often near settlements, but the relational evidence may explain drought pressure, reduced water access, disrupted grazing, family safety, and the responsibility of community leaders to prevent conflict. So the method does not produce a score. It produces a governed evidence record. What was observed, why it matters for biodiversity, who has the authority to interpret it, what can be shared, and what must remain protected. The methodology and the toolkit are living documents. Over the next 6 months, we aim to refine both with Indigenous partners, incorporate feedback from the GEO community, and test the approach through 2 Indigenous community pilots. AI can read patterns, not responsibility. This is why these 2 tools need to sit together. The relational values methodology helps communities define what should count as biodiversity evidence in the first place. It asks what relationships are changing, who can interpret those changes, and what can be documented safely, and what should remain protected. Whilst the ethical AI biodiversity toolkit follows what happens when the evidence begins to move, through data sets, platforms, model, visualizations, publications, funding, decisions, and policy processes. In the age of AI, these 2 questions cannot be separated. Because AI systems do not only process data, they shape what becomes visible, what is treated as evidence, what is prioritized, and what is funded, and sometimes what is governed as well. So if indigenous knowledge enters these systems without authority, context, and limits, it can be extracted very quickly. But if indigenous governance shapes the process from the beginning, then AI can be used more responsibly. And this is the contribution here, not simply more biodiversity data, but better conditions for knowing, sharing, interpreting, and acting. And the next question is where this work lives, where this work will live in GEO. For us, the GEO Knowledge Hub is not just a place to upload a document. It will be a place to think about how knowledge travels, with context, guidance, permissions, limits, attribution, and feedback loops. What we hope to explore with Paola and the GEO Knowledge Hub is how these resources can become useful to GEO partners without becoming detached from the authority, relationship, and responsibility that protect them. So our models ready to become more honest, more accountable, and more capable of learning from the relationship that sustain life. Because better biodiversity futures will not come from data alone. They will come from systems that can hold evidence, authority, responsibility, and relationship together. So this is the handover. Not only how do we share knowledge, but how do we keep it governed as it moves? Thank you. Sorry, and you can access the toolkit here, and there is a feedback form as well. And it's best viewed on a laptop.
Thank you, Diana. That was great. Our next speaker will be Paulo DeSalvo, who is from the GEO Secretariat and also leads the GEO Knowledge Hub. With that, welcome, Paulo.
Well, thank you very, very much, James, and I'm very excited to meet you in person. We already met several times over videos, and I would like to express my gratitude for being invited to speak in this session. It's very emotional session. It's very, very important session. I know Diana since 2017. I think 2016. I think it's 10 years. We know each other now. And in a very humble way, I've been always trying to do my best to support the Geo-Indigenous Alliance in different demands, in different requests, and inclusion of indigenous knowledge within the GEO activities or events, because this is a precious knowledge that we cannot ignore. And I remember with so much pleasure seeing Mario, Titus, Lillian, and Omar, who's over there, to come to Hangzhou in China, where a full session was held. And after, I can't remember how many hours of flight Mario did to come all the way from Ecuador to China. So very inspirational talks. I believe that our world is losing the skills to see the invisible. It seems that we only believe on what we see. What we see is what exists. And what we cannot measure, it doesn't exist, which is not true. And I talk as we, because the GEO Knowledge Hub is becoming a community. It's becoming of a community of people who believe that knowledge is critical to be shared, to empower the ones who hold the knowledge, but also to accelerate the impact of Earth observation and protection of our planet. So on behalf of the GEO Knowledge Hub team, which is partially sitting there, Felipe Carlos from Brazil, Kalamkas Yasim Kanova from Kazakhstan, we have Letvin Pondo from Zimbabwe, and Abdul Hussein from Ghana. This is the GEO Knowledge Hub team. We're super excited to be offered this opportunity to collaborate with you. And I would like to bring you to some important concept behind the GEO Knowledge Hub, what it is and how can this really help the Geo-Indigenous Alliance on the objective that you would like to achieve. So the GEO Knowledge Hub is operational in GEO since 2022. It is a centralized cloud-based digital library, fully relying on open source software to preserve, disseminate, and support the reuse of Earth observation knowledge applications within the GEO community. So our key values are open knowledge, curate the knowledge, centralize the knowledge, preserve it over time, as we know that history is a good measure to understand where are we now with respect to the past and how are we going in what direction, and engage with the different community. So the GEO Knowledge Hub till beginning of this year has been a global GEO Knowledge Hub. think global. GEO is a global organization. It's an inclusive organization. And there are a lot of, yes, Earth observation data and knowledge that are at global level. But we've been working in a very amazing way with countries, with communities, to make sure that we do not lose the connection to the local. Because yes, you can zoom in and zoom out to the planet, and the more you can still zoom in even when you are local and continue to zoom in even farther, and all these are precious. We are truly excited as we speak, because tomorrow during the plenary there will be the, hopefully, make sure you support if you're part of the delegations, the endorsement of the in situ data strategy. And this is also critical as part of the important observation for our planet. And so by working with South Africa, working with Ghana on establishing national geo-knowledge hubs, we are excited to be able to establish it's not national, it's going to be international, a knowledge hub that is dedicated to the Geo-Indigenous Alliance. So it is important that, you know, we serve communities that need to preserve knowledge, to share knowledge whenever is possible, because it's also very, very important. I think we need to realize that sometimes sharing knowledge might be dangerous. And so having a tool that allows the community, yes, to decide in fully sovereignty to share or not yet, or probably within only the community, certain information. So we are extremely, again, I like to say this probably might be something captured within the closing of the GEO Symposium and ODOC, that the GEO Knowledge Hub will be building a knowledge hub for indigenous knowledge, for the Geo-Indigenous Alliance, that will be fully within the data sovereignty, with the knowledge sovereignty of the Indigenous Alliance. As we have been doing with South Africa, as we are doing with Ghana, as we will be doing with any community that is interested to contribute to the Geo-Knowledge Hub by bringing their inputs. So I like to also stress that structure preservation is a critical component, because yes, knowledge is power, isn't it? And when this knowledge is well structured, becomes a powerful tool in the hand of the community. I stress again, defending the sovereignty, and so fully managed by the Indigenous Alliance, and long-term safeguarding. These are critical aspects. Future generations need to know everything has been done, the legacy and the responsibility you were talking about, Diana, of what has been done in the past now for them. So these are more technical aspects, control access by the community, if need to be, because we are in a world where sometimes for privacy, for preservation, actually, we need to protect certain information. And preserve and protect it. So you will be the house for the Geo-Knowledge Hub for the Indigenous Alliance, to choose who will be able to contribute in the content, appoint the different reviewers to validate resources, control whether the content is public or restricted, curate, organize the different knowledge packages and resources. And I like to pause here somehow, because in the GeoKnowledge Hub, you are not only constrained to preserve resources such as imagery, but you can share, I heard sounds, pictures, publications, manuscripts, anything that constitute the knowledge that you consider important to be within the GeoKnowledge Hub. So there is an important value here, dissemination of indigenous knowledge as discretion of the Geo-Indigenous Alliance to be visible, respected, and acknowledged. And for Geo Work Program activities, for the Geo community, this is a tremendous opportunity of growth, right? Of integration of measurable knowledge with unmeasured knowledge. So this is to say that by welcoming you in the GeoKnowledge Hub, we believe that why we're doing this, why we are measuring the earth, why are we making picture to the earth, is definitely to defend it. And somehow I want to think that we have sometimes to change our hat in thinking not something that we would think naturally, but nature is a capital. Somehow I want to force me to think as a banker. Nature is a capital. And a polluted lake, we are in the beautiful city of Geneva, where people swim in the lake during summer, they enjoy the mountains, and this is nature. A polluted lake, it will be a damage, not only to the nature, but to the people, to the bankers. All the bankers are here, will escape. So, damage nature, it's an economic damage. And somehow by looking at that perspective, we can engage into interesting discussion with why are we protecting the earth? Is because we care about it with all those relations, but also at the end to let the decision makers really understand, we can eventually let them understand. You are having an enormous economic damage on your own country. You are losing money if you do not protect the earth. So I'm going a little bit farther than the GeoKnowledge Hub, but this is, I think, is the key message. Again, we're truly honored to be able to serve and work with you, continue to work with you and support the fantastic work you're doing. Thank you very much.
Wow, isn't that pretty cool? I mean, hopefully we're going to get a press release from this, right? Where's those geo secretariats are running around here? But no, seriously, I appreciate Paulo and your leadership for sure, and approaching this new direction, new era, maybe new era of geo going forward to really elevate indigenous knowledge and the people that hold it. Let's not forget the people in this work as well. And I thank my my panelists here today. You know, you heard, you know, I don't know, it's like over 100 years of experience here on this panel, working with indigenous people, working with our knowledges, but also working broadly around the world in this area that that's important to us. And I think that because I do get questions sometimes, like, why are you going to Geneva, Switzerland? What's that got to do with indigenous people or the knowledges that we hold or the future on climate change and biodiversity loss and those cultural loss and things like that? But I have to remind my people and others that we have to be here. If it's not us, then who? You know, we have to build these new tables for collaboration. Not just, if somebody says, if you're not at the table or build a new table, you're on the menu. Well, I think indigenous people don't want to be on the menu anymore. And I think that requires leadership, it requires courage, it requires a new way of thinking. And it's my hope, and through our work here, that the GEO community here, including you, will hear the things you heard today and this week. We'll take that back to your communities, your organizations, to have those conversations about the importance of what you heard today in terms of indigenous knowledge and what Paulo talked about, opening up opportunities for us to bring ourselves into this work, to hear our stories. When I think about that knowledge hub, I'm thinking about stories. I'm thinking about different ways, different modes, how information is shared, different modes, how information is transferred. What about movies? What about those things that really begin to speak? And what about our languages? Can our indigenous languages be in that knowledge hub? And what would that look like? How would we do that? And how and who would do that work? And how would we compensate them or honor them with that knowledge? I think that's important because that says something about how you work with our people. And so, so those are things for your edification today. And we have 15 minutes. I was going to give another talk to you guys. I'm kidding. But we want to open the floor up today now and for your questions and comments. You want to... Last slide, please. Okay. So we want them to say it again.
We would love to have your feedback now. So we'll leave you about 7 minutes if you can work in groups and answer those questions. There is a feedback form, and then we'll ask you to report back in 7 minutes. Thank you so much.
3 more minutes. 3 more minutes, and I'm going to ask every one of you to report out. I'm looking at you two right there as my first cohort. Also, if you can record your comments online, because we're not going to have enough time to go through with everybody here. But if you please record your comments to these questions, we'd greatly appreciate it. 1 more minute, and then I'm going to be calling on people. So don't leave. Be brave and share and care. All right, ladies and gentlemen, it's report out time. As promised, those 2 young ladies right here, would you mind sharing one comment or your thoughts with us?
My name's Kayla.
I'm Clara.
And is there a particular one you want to share? Maybe the first one. Okay, we'll answer the first one. So the question asks, why does this work matter for GEO? And we said it's a voice that needs to be included, that has historically been left out. So there needs to be a change in how we grow together in this new GEO community and further than that as well.
Very good, thank you. We'll stop right there. That's too good to. How do you improve on that? How about you two here at front? Yes. Oh, I forgot. No. Anybody else want to share their response to the questions?
Or any other comments?
Or any other comment? Yes, sir. In the blue.
But ongoing thoughts around question 3. What's missing, difficult, or risky? Barriers to take that. I just thought that there's a challenge here, which I think you kind of pointed out, in that there's a vast difference between a global Earth observation system and the lived reality of local indigenous people. And bridging that gap is going to be eminently difficult because, of course, there are indigenous communities all over the world. How do you kind of try to bridge to those communities on a case-by-case basis?
Good. That's a very good comment. Thank you for your perception. Anybody else? Yes.
Hello, my name is Kalamkas. I'm representing the GeoKnowledge Hub. I just would like to say that, for instance, I'm coming from Kazakhstan, from Central Asia, and we don't really work with the indigenous communities, with the data that indigenous communities producing, and generally the framework when GEO, as Paula mentioned in the presentation, think global, act local, but also it can work in the opposite way, bringing the local knowledge to the global level and disseminate it around the globe. So, for instance, me who never worked with the indigenous communities or never faced, in my research, let's say in my career, with someone working with such information for such data, I will be aware of such frameworks, such rules, how to deal with this knowledge and data. So I think this is what I would add. Thank you. I hope I express myself clearly. Thanks.
Yes, sir, in back. White shirt.
Yes. Thank you. Um, I come from northern Kenya. Around 2022, there was a severe drought that affected the communities in northern Kenya. So there was severe drought and then repressed rainfalls. So uh, after that drought episode, some projects which are focused on drought started being implemented in northern Kenya. So one of the projects I supported was on enhancing effective anticipatory action around that area. So one of the deliverables was to do research on what are the anticipatory action mechanisms available. Is there early warning system that can reduce the impact of drought and so on? And we had a session with the community, and the communities have their own early warning systems. But what we have in the science world is we have the knowledge that that exists on how to do anticipatory action using climatic models and so on. But the system that the community has is not documented. Hence, it's not something you can cite in a research paper and say this is a method that can be used to enhance anticipatory action. So the challenge I want to highlight is the lack of documentation, especially around the knowledge that those communities have when it comes to early warning systems. So through that project, we were trying to document some of them, but there's a lot of gaps in that. Thank you.
Hello, Gino Notocabraulio, Colitonelli. I speak, this is the Aztec language, the Nahuatl. And I have two ideas that comes to my mind. First of all, is that I see that the platforms and ideas, the proposition are mostly from like English-based countries, because then it can easily be translated to indigenous peoples from Anglo countries, and I'm from Mexico. So for this matter, there is also like a big inequality access in terms of education for this kind of technologies, even for experts that are working in the matter. And here's the thing, like for example, myself, I do speak a bit of Nahuatl, but I don't want to be the spokesperson because I did not grow up as one, and I don't want to like overstage someone else's place that it's like it should be theirs. And secondly, this is also comes like from personal experience actually, because I used to work for an agri company in my home country that trained small businesses when it comes to like sustainable farming and sustainable agriculture. And it was easily like we were very wary when it comes to like the kind of services and technologies that the government would provide us in terms of how to train the communities we were working with. And this would always come to like this is like one of the main issues in working in developing countries when it comes to in a top-down scenario. There's always, you gotta consider the corruption side. So it also, like for me, as I work for, if I work as a decentralized, like out of the state system as an NGO or a private company, it will be easily for me to like grab and have access to the GeoKnowledge Hub or any kind of data repository in order to give access to it. But also, like, what comes to me is like how, and it's also a question I ask myself, like, how do you handle data property? Because if for example, if I have a drone, or if I'm a Landsat or whoever, and it goes to an indigenous area, and I do like high resolution images, like who does it really belong to? Like, do people who live there, or who people is taking the picture? So that's also like, that's a challenge just on the fact of epistemologically speaking, just like how can we address this in order to make it into policy?
You know, I want to just offer something here based on your comments to this point. I think there's an opportunity for education. And in terms of, to your questions about, well, I would call that indigenous data sovereignty issues about the drone and the data, and who owns it and who's access. I think that, you know, in my view, you know, we don't stop learning. And it seems to me that GEO is a learning community, and the issues are complex with indigenous people and our knowledges. We understand that. But at the same time, we know that we need to make advancements. We need to make opportunities because we believe in a just world. We believe in opportunities for all. And we as an organization really should think deeply about embedding indigenous-led educational opportunities, experiences for our members. But also, what would that look like? I thought, do we have a Geo Academy or something like that here, or something that that teaches different things about technology? But what about people? What about cultures? You know, why, and languages? You know, why can't we approach that? Because I think, you know, we're a global community. Why not begin to make those things offerings and think deeply about how we bring those things forward, led by those particular communities. So, are we out of time, Diana? All right. Well, let me say thank you very much. In my culture, we say "Wopila tanka chichapalo." It means thank you all very much for your time and attention. Again, don't forget to give us feedback on our forums. And thank you for being with us today. And hopefully, it was beneficial to you that we can continue to carry the work forward in partnership. Thank you.
Let's see. Yeah, I think we can start right away. Okay, we are about to start the session. Could you please take a seat and move over into the meeting room?
Yeah, it would be nice. Thank you so much.
Do we have a, yeah, at least we have a panelist here, everyone. So please take a seat. We are about to start another exciting moment, a joint working group meeting. So once a year, all the working groups of GEO and also bring together relevant GWPs. So we talk about grand global challenges and how Earth's intelligence can serve. So this year, we have a topic, urban risks, shared data, knowledge, and solutions. So the idea is we focus on urban area. We talk about challenges and solutions, especially nature-based solutions. Well-used data and knowledge, especially local knowledge. This joint working group meeting has been here. This is the first time. So since the new structure of GEO, we now have 3 working groups, DRA and Resilient City and Human Settlement and the data and knowledge. So once a year, we have this joint meeting all the way from Cape Town to Hangzhou to Rome and now in Geneva. So here's structure of this session. We will first hear from working groups and see their perspectives about this topic. And then we will have a panel input reaction, especially for GWPs. And then we will have an open discussion and hear from the ground. And hopefully we have reached some kind of agreement and then move forward. So I'm the moderator, Gen Shuijia. I'm from Chinese Academy of Sciences and co-chair of DRA working group. So we're talking about the structure of the session and about the proposed directions. So a little bit about this working group. After a new structure, we have a climate change working group and disaster risk working group merged into one. And now we call disaster risk reduction and adaptation working group, or DRRA. So the idea is start from climate change and extremes. So we're targeting UNFCCC, and then talk about disasters, especially those disasters relevant to extreme climate. And also linked to Sendai framework. And then we put them all together, talk about climate extremes, disasters, and biodiversity nexus. The idea is focus on climate-driven disasters and nature-based solutions. So it's cross-cutting among the GWPs. So this slide probably can, can explain the main topics of this session. So we care about grand global challenges all the way from climate change to disaster risks and to declining biodiversity. So there are both challenges, also solutions. So we know that climate is changing, especially causing extremes. I think back to 5 years ago when before the AR6 of IPCC release, it was not very clear about the linkage between climate change and disasters. But now it's much clearer. And so there's increasing of disaster risks. And in the meantime, biodiversity and ecosystem services are also declining. But altogether, when we restore ecosystem, that means we also have multiple solutions. We're targeting the restoration of ecosystem and also nature-based solution for climate change. So this is the main topic today. So the purpose of this session is advancing convergence across GEO working groups and working programs activities by presenting 3 concrete collaborative directions. I will list them later on. And gathering feedbacks and contributions from the ground. And then hopefully we can identify which ideas have sufficient traction to move forward by the end of this session. So here are the 3 proposed collaborative directions. Creating a GEO knowledge hub nexus. Topics including urban resilience knowledge package. And start a use case in urban coastal resilience. And start a case in high mountain rapidly urbanizing cities. So those are the 3 topics. Those topics are not coming from nowhere. About 2 months ago in March, we had an open house webinar. I think many of us probably on there, an online meeting. And during that meeting, we also focus on disaster risks, climate and biodiversity nexus. I brought together of land degradation neutrality, geotrees, GeoArc, Digital Earth Africa, and indigenous aliens together. So we discuss the topics and try to find the future direction. So here are some conclusions from last webinar. And we recognize the risks from multiple challenges are interconnected. They are interconnected challenges, so they cannot be handled separately. And we focus the importance of in situ observation, especially from local knowledge. And we also find that we must be translated, nexus must be translated into real world decision, text, context. So based on this, we have those 3 directions proposed. And we like to, so this is a barcode. During the meeting and also after the meeting, like to hear from the ground and also online. So you can scan the barcode and put your input. Basically talk about which direction are most relevant you believe and how you plan to contribute. And also I'd like to hear about who you are and your background. So together with me, we have leadership from working groups and several GWPs. So later I will introduce them. First, I'd like to invite two working groups to give a framing presentation. The first, I'd like to invite Kamakas Yasim Kanova from Data Knowledge Working Group and also Knowledge Hub. Welcome.
Hello, everyone. Thank you for joining us today. So, yes, as already mentioned that I'm representing the GEO Knowledge Hub and member of Data Knowledge Working Group. I would like to just give briefly about the GEO Knowledge Hub. So just to give a little bit context, so to understand what the proposal later will be about. So the GEO Knowledge Hub is the digital library of GEO to preserve, disseminate, and support the reuse of Earth observation applications developed by the GEO community and shared with the GEO community and beyond. So in the GEO Knowledge Hub, we have two concept of a knowledge package and knowledge resources. So as you can see on the slide, there are different types of knowledge resources like satellite imageries, institute data, scripts, articles, and so on. And most of the time they are scattered in different places on GitHub, can be some training materials on YouTube, institute data on local drives, and so on. And to centralize all these resources, we have the concept of a knowledge package. The aim is to organize all the resources that used to create that knowledge, that application in one knowledge package. And each resources and the knowledge package itself has metadata. So like title, who are the authors, contributors, some keywords, date, and so on. And then resources itself and also the knowledge package both can be supported with files. So you can basically upload the data sets itself, the documents, so any types of files, and auxiliary resources. So to preserve this, we also, to preserve this knowledge and data and think about for the sustainability aspect, we can assign the digital object identifiers for the resources and package itself. And this is one example for you to have an understanding if you never experienced the GEO Knowledge Hub, how the knowledge package looks like. So you can see the packet, the page of the knowledge package coming from World Pop. You can see at the bottom the resources, has dataset, publication, and software and other categories. And this package includes different types of resources. So it's basically a dataset. They have the method, they have the application, and the actual content of those resources are the tutorials, the application itself, the data they have used to produce this. So different type of content. So this is just to show you the quickly the overview of the package and resources in the GEO Knowledge Hub. And as we are today having this joint meeting, they would like to propose like two. So we have two proposals. One is that the joint working groups activities can be supporting not GEO Knowledge Hub, but the activity, the community by publishing the content. So it can be the packages or resources, or the second one is defining a vocabulary for these proposed nexus topics. So in the GEO Knowledge Hub, we have vocabulary system to help enrich metadata of packages and resources. So how do we do this? For instance, by the each resource and package can have the thematic focus areas. They can also include SDGs, Paris Agreement, a new urban agenda, and so on, or some defined vocabulary for the GEO communities. And the proposal is to develop vocabulary for this specific activity. This way, it will allow semantic consistency, and then it will also help for discoverability of the content, especially when the GeoKnowledge Hub is integrated with other systems. One example can be like Henry Hub next integration with the GeoKnowledge Hub. So this is another aspect. And also, once the vocabulary is defined, this can be applied for either new content coming to the GeoKnowledge Hub, or we can also map these existing content which is already in the GeoKnowledge Hub. So this is basically the proposal from the GeoKnowledge Hub team, and we're happy to take the questions after. Thank you.
Thank you, Klemkas, for perspective from working group. I'd like to now invite Martin Clark from City Resilient Working Group.
Should I use this one?
Yes.
Yes.
Yes, right. In between, or maybe this.
We can use both.
I don't think so.
Oh,
Camera's
yeah,
not.
can you only one? Right.
Not ideal. Okay. Thicker. I think everyone can hear me in this room, probably, but hopefully online. Okay, so we have a couple of things to show you this afternoon, mainly from the perspective of the Resilient Cities and Human Settlements Working Group, and some things that we are already working on. So both myself and Thomas Kemper at the far end of the table represent that working group as co-chairs. We have about 25 active members at the moment, which are broadly from the Earth observation community and end users community, should we say. In our case, city networks, people that represent decision makers, policy makers, practitioners working in urban settings. We've got three kind of activity areas, and I want to draw attention to one of those today, because the proposal in this session is that we could adopt a similar approach to defining a use case, which we've been doing in the Resilient Cities Working Group, but apply it to the nexus area that we're discussing today, disaster risk reduction, urban and nature biodiversity. So what I'll try and do in a few minutes is just kind of describe a process and give you a concrete example of what we've been doing. It's halfway through, so we haven't completed this yet, but essentially it also links to what Callum Cuss just presented, in that we are trying to, from bottom up really, define a use case. And by use case, I mean a decision-making context, and then map that to Earth observations, capabilities, data, information, and make that available as a knowledge package so that it's a kind of lasting artifact that others can pick up and use. So I'll walk you through the process. It is very simple, and I'm absolutely sure that there are other ways of doing the same kind of exercise. We've been doing this, it's quite simple, as I say. But really it starts with trying to define some decision support needs or policy making needs. And from there, working your way through to how you link that to the potential capabilities of the Earth observation community. I will state up front actually that in all of the examples that we've been working through, and we've been using really the broad kind of domain of urban climate resilience or urban heat resilience, is that in virtually every case, it's not just mapping to EO capabilities, but it's also identifying other types of geospatial, statistical, public health information that you need to integrate with Earth observations. anyway, we picked a kind of broad topic area, urban heat resilience, then through a series of interviews, and that's with some of our partners in city networks, cities themselves, folks implementing projects in the domain of heat resilience, and some desk-based research. We basically defined a compendium of 10 use case narratives, which is really just describing a decision-making context and the kind of systems, processes, governing arrangements that frame those decisions, and hinting at the kinds of data and information that a fictional person essentially needs in order to make those decisions. We've got the compendium complete, and I'll share a link of it to that in the chat. But the next thing we did, and we've just completed this, was to present the use cases at a workshop just to validate them and make sure that we're others agree that we've accurately captured how these decision-making contexts are described. The next bit that we're moving on to is to really then map that against data and information needs. And I'll give you an example now, just so it's a bit more concrete. But just as a slight relief from all of the text, we also kind of picked 10 use cases that spoke to a variety of temporal and spatial decision-making contexts. So some of these, as we're talking about climate change and the impacts of climate change and heat on urban residents, people that live and work in cities, some of these decisions are those that are taken in a very short sort of operational time space, hours or days. Some of them are looking a little bit further ahead, days and months perhaps, and as you see from the graph, looking further into the future. And we tried to capture a range of these, but we also tried to think a little bit about the institutional and economic context that some of these decisions are made. I would say we are comprehensive in this range of use cases we captured, but there is some level of generalization there too. Anyway, I'll just look at one in particular. And I thought this one was quite interesting because it sort of already speaks to this nexus area that we're discussing today: urbanization, nature-based solutions, and disaster risk reduction. And in this case, we have a kind of fictional user, a city urban planning director, who is looking at trying to make investments in green infrastructure, planting trees, developing parks, maybe regenerating parks, and trying to introduce some kind of nature-based cooling. We tried to describe in as much detail as possible some of the factors affecting how that person makes the decision. And as I said, this came from interviews with actual people doing this job, so it wasn't made up as such. So this person is clearly operating within some budgetary constraints and an enabling environment that sets out how they can plan. The next thing was like defining the actual decision. So really the director is trying to develop an investment plan for the next 5 to 10 years, which basically describes where and when to introduce green infrastructure and the intended benefits, and a costed plan so that they know how to mobilize resources for those investments. Then we get to a bit more concrete information on the types of information that person maybe already uses, or in a perfect world would like to have access to. So things like land surface temperature data on land use, on population, an existing inventory of green spaces, but also setting out a little bit of the context of what is not working in this current decision-making context. So perhaps the data sets are very fragmented, not integrated, and that's something ultimately they would like to see. And then we sort of put a sort of description on what the world would look like if it was more perfect, the types of metrics, data and information the director would need in order to strengthen the plan that they developed on investing in green infrastructure. Anyway, you can see it's kind of a very narrative, easy flow summary. This is a little bit of a summary of the compendium, but in any case, these are very simple narratives that we developed in conversation with people just like this. And then the next stage, as I say, is to then try and map that to more specifically the types of data and information that we need in order to understand thermal stress in an urban environment, how and how that would change, how it's changed historically and how it would change over time. Something around capturing the existing stock of green space and maybe the extent, but also the condition, and some of the cooling benefits that are already being provided. And then, as I said, some hints at the types of non-EO or non-climate data that this planning director might need to combine with the climate data to understand exposure and vulnerability and potentially impact. We also touch on some things like the fact that they are unlikely currently to have the right spatial or temporal resolution of some of this data and information. And so we've put the kind of models or data products that this director may need to access in the future. Anyway, the idea is then we package all this up for all of the use cases. There's another round of validation with the EO community, and we can then publish as a knowledge package in the GEO Knowledge Hub, and it becomes a reference resource for others to use. Maybe just one more slide. So I think we have two potential use case areas on the table already. Jensen, as you say, they didn't come from thin air. We discussed these at an earlier meeting, one on coastal settlement resilience and one on mountains. One other thing that we could offer, I think that we could start to think about, depending on which use case we select, is where we might like to think about adopting this use case framework, who we could go and speak to. So the logos on the screen speak to some of the members of our working group. We have very good connections with many of these, and they in turn have very good connections with city governments, urban local governments in very many parts of the world. The map is showing the location of the C40 city network, which is about 96 cities. Global Covenant of Mayors have something like 12 or 13,000 cities. And then some of the other groups on the slide here also allow us to kind of have that outreach to speaking to people who are trying to make decisions on disaster risk reduction in the context of urbanization. One I will definitely draw attention to is MCR 2030, because that's a UN Office for Disaster Risk Reduction network initiative, which also is probably a very suitable entry point here, where we have direct connections to cities who are thinking about DRR-based activities. And I will leave it there and take any questions, or maybe we carry on.
Thank you, Martin. Yeah, I think for the concrete ideas about resilient cities, so now we already have a perspective from 3 working groups. Now I'd like to invite inputs from 2 highly relevant GWPs. So they are Global UAV Network and also Earth Observation for Disaster Risk Management. So I'd like to hear about the relevant ongoing works and also how their activities can link to and support proposed ideas. The first, I'd like to invite Yue Huaying from UAV Network.
Okay, good afternoon, everyone. I'm going to report the progress of the capacity building on the construction and applications for Global UAV Observation Network. Briefly to Global UAV Network. This is a new GWP, which is initiated by 3 countries, the institution from 3 countries, China and Nigeria and South Africa. Okay, this is outline. The first is the UAV networking. And as we all know in recent years, the UAV remote sensing has been widely used in many fields, by the virtue of the compactness and flexibility and quick response and high precision and cost effectiveness, and unrestricted by terrain with centimeter precision geospatial information requirement. The UAV remote sensing increased rapidly in the past 10 years. The quantity of remote sensing UAV is estimated to surpass 1 million units all over the world. And recently, the UAV remote sensing technology has the trend as networking from single UAV to large-scale network. And autonomous unmanned operation without UAV pilot in the field watching. UAV observation network has become the only means to simultaneously provide centimeter level observation data and achieve extensive coverage. And the technology of UAV automatic hangar makes the construction and deploying of UAV observation network possible. The hangar is a highly integrated, fully automated unmanned operation platform. It's designed for UAV parking and automatic operation. It provides reliable support for UAV automation in takeoff and landing, the battery charging, environmental monitoring, and remote control, and ensuring long-term stable operation of UAVs. The hangars play a very crucial role in UAV automation and intelligence operation. Generally, the UAV observation network has three major parts. The first is the hangar for UAV storage, taking off, and landing, and charging and power exchange. The second is the UAV plus the payloads. And the third is the center control system. It serves as the creation and the assurance of missions, real-time monitoring, and the UAV operations, and the data processing and analysis. And combining the automatic hangar and UAVs, we have developed 4 types of UAV stages. They are lightweight, for example, the lightweight UAV station and the multiple function UAV station and long endurance UAV stages and the carrier type UAV stages. And also we developed the Zhongke Skynet UAV cloud platform to control all these UAV stages in network. It's a UAV observation network operation system. It integrates UAV command and scheduling, mission planning, and data management, and analysis and application. This platform is controlling more than 10,000 UAV stations we have deployed in China. And after 1 year's diligent efforts, we have organized the 9 institutions from different countries over Africa, Asia, and Europe. They all have the requirement of application of UAV observation network. Now, this is an example from Nigeria of the oil field inspection. And we have signed the agreement, the research agreement with these institutions. And with the National Space Research and Development Agency of Nigeria, their demand of energy infrastructure monitoring and ecological and environmental monitoring. And for the National Transmission Company of South Africa, they are going to use the UAV network to do the power line inspection. And for the Utava AI company of Serbia, the urban environment monitoring and ecological monitoring requires UAV network. And for Senegal, the wildfire need to be monitored by UAV, and for Nepal, the ecosystem and land use monitoring in the mid-mountain area of the West Himalaya and disaster risk monitoring, and Maldives marine environment monitoring and marine disaster early warning has the demands of UAV network. With all these corporations and the promotion of this GWP, we propose to establish the UAV observation network as a part of GEO infrastructure. Under this framework, with the corporations include the technical research and the application development, we hope the UAV network could fill the observation gaps that are not covered by satellite remote sensing and the field observation, and it will serve as a decision-making need of local government and support the implementation of GEO post 2025 strategy, Earth intelligence for all. Okay, thank you.
Thank you, Huiying. Now I invite Jampi Hakami from EU for DRM.
Okay, thank you. Nice to meet you all. My name is Junpei. I'm now working at the UNSI Inspire team. Yeah, honestly, I didn't know so GEO knowledge hub before I joined this one, but thank you so much. I like the idea for your current class, your package, your platform, and also Martin, your framework, yeah, bottom up base in the mapping system. So might be some my use case could be one of the stuff. So yeah. My position, of course, I understand EO for DRM. Yeah, usually so the UAV is also filling the gap, so the more close, small scale, but also EO4 can here take a big scale. So of course, Unispire is a disaster base, but this Tonga project has also covered not only DRR, climate, and then possibly a mangrove, so the biodiversity nexus. I can align to the this topic theme, I hope. So Tonga project was launched in 2023, and then the whole year 2024, we co-aligned with the CEOs and then developed remote sensing because they requested in the PGRC Pacific Remote Sensing GIS conference. They requested us to make we need a sustainable remote sensing platform. Okay, yeah, Geo server is also free, and then also we call the Airbus and then any other JAXA or any other space agencies can provide in-kind contribution for the higher resolution and then also product. So yeah, based on that theory, so we provided this platform to Tonga. Sorry, but I'm gonna skip. But if you need, if you want, look at this YouTube videos. We uploaded any promotion videos on the platform itself. So you can type in a Tonga disaster preparedness platform, and then yeah, you can just
observation imagery
touch on the actual platform.
Proactive
so,
in empowering nations to respond to the threats of climate change.
The voice is very great. Yeah, great. Okay. It's good. It's good. Yeah. Without any, but it's cool. And then also we published in the Summit of the Future in the UN, and then also digital twin is one of the great asset in this project. Sorry, another videos again. So YouTube has, or we have a YouTube, and then these kinds of promotion videos, and then of course based on end user requirements and then voice, Tongan people let's say Ministry of Climate Change and then Ministry of Statistics, they need a very high resolutions, and then they didn't even know so the highest resolution in the world, so the 30 centimeter. I hope a 20 centimeter in the next. Hopefully this next. But in this project, so we all stakeholders is an in-kind contribution, and then putting their time and then power on providing a higher resolution product, mangrove extend, and then also the building footprint, and then digital twin product, and then synthetic aperture radar satellite by ASHI, and then JAXA, and then any other commercial satellite data provider, and then we analyzed kinds like land subsidence, and then also the land use and then land classifications as well. Yeah, this is a platform overview, and then you can check and you can search on this software GEO server platform. By the way, yeah, of course, due to like yeah, this project is all in kind of contributions. We don't get any funding, so that's why any great like ArcGIS online, so great UI, but it's still good because it's a fast step in Tonga to get in more like so the how EO can contribute on the management of land management in Tonga Tapu. Of course, Sheets Islands country doesn't have a main island. There, of course, scope for other islands. That's a very inhabited like island has a very serious issue. No any data collection methods. Okay, so yeah, I was there. So the Tonga first remote sensing and GIS workshop in Tonga. It was so great. Yeah, nice beach and then nice weather. Of course, I promise I did my job. Of course, right. Yeah, that's why I did. Yeah, this is my proof. And then they are so nice. In this workshop, not only disaster risk management stuff, any Ministry of Climate Change, Ministry of like Fisheries, and then Ministry of like Statistics, all put in the same pocket and then room. And then I just like demonstrate how to use like Google Earth Engine, QGIS, and then ArcGIS deep learning package. Because even like Tonga, they have a different GIS software, QGIS and then ArcGIS. So maybe to make it clear, so the how to separately using that for each applications depending on the tool. Okay. Yeah, digital twin. Maybe Laurent in the morning. So last 2 minutes. Digital twin is based on from this is also new, and then space data, and then Black Shark AI from US and then Japan space startups also in kind of contribution developed photorealistic digital twin product. Okay, I want to skip because Pacific doesn't have any like the great data set in digital twin product, because sometimes like Google and then IBM and then Microsoft has the global data set, but they didn't cover like building height information. So from my side, so the message to this working group. So EO, of course, we can provide any like use case like a Tonga, and then not only Tonga. So we provide like Ghana and then Trinidad and Tobago, any Sheets Island, because UNUSA is taking role like a Secretariat of Space for Ocean Alliance. So Sheets is very keen to the focal point from our side. So from my side, might be like a second point. Third point, like EO institute data and then socioeconomic indicators. These three components are very great DRR, climate, and then biodiversity nexus. So that's a great my summary. Sorry, yeah, I can summarize for this third point. Yeah, from your presentation, based on your presentation. Thank you.
Thank you, JP. I think this is very relevant and informative. As mentioned, that there's a joint effort between the working groups and working programs. So now come back to working groups. I'd like to hear the reactions from the working groups and about feasibility, about data and integration aspects, and also about opportunities for working group coordination. I'd like to invite co-chairs from two working groups, Helen Glaves from DK Working Group and Thomas Kemper from Resilient Cities Working Group. First, Helen.
Yeah, thank you very much. So thank you for the introduction. We don't have slides, thank you. I'm currently the co-chair of the In Situ Data Working Group in GEO, and part of what I've been involved with recently has been some of the work around developing the GEO Knowledge Hub, or at least being on the periphery of some of the exciting work that's being done to develop the GEO Knowledge Hub. So I've been really pleased to have the opportunity to come here today and comment on an initiative that potentially builds on some of the work that Callum Cass has actually very eloquently provided and given a wonderful perspective on the capabilities of the GEO Knowledge Hub. But I also wanted to make some sort of broader comments on the concept of the nexus from DRR and climate and biodiversity, because I think this is a really powerful example of how different GEO work program activities can come together and work on common problems and actually leverage the activities that are happening in the GEO work program activities. I think from the perspective of the Data and Knowledge Working Group, I want to say that I think what's been presented today demonstrates the fact that there are a number of activities that can be integrated together that actually deliver added value for science and society. And certainly what we've been hearing about and the feasibility and the potential of developing this nexus within GEO highlights the opportunity to really promote the GEO stated mission and objectives within the GEO post-2025 strategy. I think Callum Cass has already showed a lot of the potential of how the GEO Knowledge Hub can support the creation of this nexus, both in terms of providing the resources for sharing the different data, but also the integration of the data and making the data as widely available and reusable as possible. And I think this is a fundamental part of what needs to be achieved. I would also say that I think the creation of this nexus provides also a fantastic model for how other GEO work program activities can come together in the GEO context and actually bring an added value from leveraging the expertise from more than one GEO work program activity. I also just quickly wanted to say something about how I see the formation of this nexus also supporting the GEO's in situ data strategy, which is very close to my heart at the moment because we've spent the last 7 years developing this strategy for GEO, which is aiming to actually ensure that in situ data is recognized as being as important in the GEO context as satellite-based observations. And I noticed in a number of the presentations that we heard from the panelists that in situ data was identified as being critical for the activities of this nexus. And I think the other thing that I also wanted to say was that I think this nexus demonstrates that there are a number of the priorities that are identified in the in situ data strategy that potentially will be directly addressed by the development of this nexus, particularly around integration of multidisciplinary data across different communities and different activities, but also ensuring that this data is as widely available for reuse as possible. And I was really excited to see my colleague here's slides where there was clearly direct activities with the communities who would benefit from the formation of this nexus. I think that was a really important message, not just for the activities of this nexus, but for GEO as a whole. I know Paolo's been saying a lot this week about co-production and, you know, the power of working together. And I think your exemplar that you just gave was a really good one, even if you did have a good time on the beach as well. I think the other thing I wanted to mention, and again, my colleague here has been working in Tonga, that I picked up from this is also the potential for this activity to identify some of the critical data gaps that exist in observing systems, and particularly the in situ observing systems, and how there are some really innovative approaches. We heard about the UAV network. You know, all of these types of innovation within the context of this nexus allow not only the identification of the data gaps, but potential solutions that then can be integrated into the geo infrastructure. So I think this is a really exciting opportunity for GEO actually to develop this nexus and then to leverage the tools and activities that already exist, but also to promote some of the priorities for GEO with a really tangible and solid use case that cuts across multiple GEO work program activities. And I have to say in conclusion, I was really excited to see the potential and the opportunities from this broad collaborative opportunity that I don't think only leverages the opportunity for collaborations in GEO, but also potentially forms those collaborative relationships that build the GEO community, but also enhance the resources that GEO is able to deliver via the GEO Knowledge Hub. Because ultimately, we're going to, through these activities, have additional data resources and tools and services that are not only available to the activities of this nexus, but also to the broader GEO community. So I was really excited to hear about all the different facets of what's being thought about in the context of developing this nexus. So thank you.
Thank you, Helen. Now, Thomas.
Yes, thank you. You gave me a hard time now because some of the points
Sorry,
you addressed, I would have mentioned. I'll try to not repeat myself. But first of all, I wanted to step out a bit and really thank the dear Secretariat and those who made this event happening and make sure that this event is happening every time we meet, sort of, because I think this is really, really crucial because we have a disaster risk working group, the Resilient Cities and Human Settlement. Already Resilient Cities and Human Settlements, you see a huge overlap of the two. And yes, we try to talk to each other, but we are all very busy. We try to work in GEO on best efforts. So we need really events like this to come together and see where are those overlaps and how can we maximize the little contribution that we can make here. So that's really where I think this is already a big win that we are sitting here together and can discuss. So that's sort of as a pretext before then moving into the reactions to these new ideas. Again, when the new Knowledge Hub was created, we were one of the first to support this. Here I should mention, I'm speaking here with several hats. So there's on the one hand my co-lead with Martin of the Resilient Cities and Human Settlements Working Group, but I'm also contributing even longer to the GEO Human Planet initiative. Then I'm also at my day-to-day work related to Copernicus Emergency Management Service. So there's several things that I'm trying to bring here together, and I don't want to separate them because again it's things that are connected and should be connected together. So the GEO Knowledge Hub, to come back there, was really for me a milestone in this approach of making knowledge accessible and not just a link to an FTP where you can download and maybe you get a README that tells you this is data from 75. So really this is a big achievement, and I really think we need to develop this further, and hence I'm also very happy to see this presentation at the very beginning to see how we can broaden up and make it maybe even more easy to find what I'm looking for, because I mean, we grew up in GEO, most of us here, but for outsiders, it's very complex. So if there's a new entry for people from the outside that work in biodiversity and just type biodiversity and then get something out, I think this is already something that will help also to in the mission of GEO to broaden the use of Earth observation. So that's already very good. And then the other two more concrete examples I think are as important because they are concrete. So they really talk to decision makers that maybe come from other contexts, but they see that Earth observation combined with in situ data can be also used at the very local level, and methods can be reused also in other contexts. And that's something, again, where I think we have a big opportunity here to bring all the knowledge from the different working groups and then work program activities. Also, I think that's important that from the working groups we reach out then to the connected work program activities to really get all the knowledge we need for those use cases. What I think we should really focus on is then what is shown there as the first point, the feasibility, so that we really reflect on what can we really achieve with the resources we have here, so that we don't promise something that starts as a Ferrari and then comes up as something much smaller. So that's, I think, one of the things that I would take also as one of those criteria for then seeing which direction we should go. And maybe we can even see if we come up with a good idea. We don't have to make a selection and choose one of those Lido points, but we can see that by working on one or two of the use cases, we can contribute already to some of the development of the knowledge package. I think that's for now my contribution. Thank you.
Thank you, Thomas. I think now we can move on. I'm back. Open discussion, reactions. So this is a very important part. So we'd like to hear from the ground, from the broad GEO community, online and on site, about proposal idea, about how you can contribute, and also cities or regions or partnership. More importantly, about yourself. Yeah, good.
Well, maybe I will not answer your direct question, but nevertheless, I would like to second what Helen has said. I have been seeing things presented that are really. I'm seeing this from the in situ data working group, so I'm repeating myself. I'm seeing things presented that really map with the interest of the in situ group, and in particular to the deployment or implementation of the in situ strategy that we all hope can be, supported by everybody tomorrow. So, for instance, the UAVs that were presented, we have a dedicated sentence in the strategy that says incorporating novel sources of in situ data such as citizen science, Internet of Things, and drones, parentheses, UAVs. So it's definitely something connecting, and this we can generalize, no? So it's a bi-directional collaboration. This is what I'm trying to say. You are providing this new view from these kind of new platforms that are precisely necessary to implement the in-situ strategy. And this is just one example. There are plenty of other examples where these activities can also be collaborating with the implementation of the in-situ strategy. I'm really happy to see those, even when you sometimes misuse the term Earth observation referring it to satellite. Maybe it's because actually it's not a misuse. Maybe it's because actually you are referring to Earth observation as satellite, but also complemented by in situ. So again, it goes into that direction. And of course, the identification of gaps that was presented. So just going into a particular detail. So again, we have these GREX. We have been thinking about how the requirements presented to us can be actually covered or filled, and we have some, we call it pathways. One of those is a new sensor, a new technique appears in the domain, and now this new technique can somehow support some of the requirements that were already there. So that, and again, this is just one example of possible correlations, but I'm pretty sure that other pathways can be covered. Right? That's what I wanted to say.
I think, thank you. That's a very good description. And, generally we use UAV, the observation network. It's very difficult to, I think, in many countries, it's very difficult to have these data provided to, for example, to other group. So generally we deployed this network and obtained data for the local institution or the local government. For example, we have produced this system and these devices just how to say it, just for the cooperative partner. We just give them all the system, and they acquire data, and they and use it for the local application, for local government or local institution. It's very difficult to share the data. But I think in the framework of GEO, maybe you can use these data to share the data for different GWPs or for different group. Now we are doing this. We are trying to do the data sharing in this framework. But I think there is also very difficult. But we can try and see. So okay, thank you.
Maybe going back a bit on what John was saying, I think that this new development in drone data in terms of, data format and sharing and how you ensure interoperability between, different types of products. I think it'd be really interesting to get your insight on, what's the best way to share this data? Are there standard format to exchange it? Is it collected in a standard manner everywhere by different agents, or, is your system just one of, so I think there's a lot of dimensions that could be explored.
Any response from Knowledge Hub or UAV? Yeah,
maybe I can respond again. So I think that's a very tough question. Just as now I explained, it's very difficult because of the policy of different countries. Generally, this high precision data with centimeter level. I think for many countries, it's a secret policy for the data from the data sharing. But now we are trying to do this, and in the framework of GEO. So, but now currently we have no policy how to share the data between different agencies or different countries or different group. But I think it's difficult. But how to do it? I think we can carry on this GWPs of the UAV of the network. Maybe we can combine this activity with some GWPs or some partners in some other GWPs to use these data for the local use or local cooperative partners. I think maybe in the future we need to make some policy to share the data. But I think it's very difficult. So I don't know. I have no feedback. Thank you.
I would like to come in here as well, because I'm now with my head of Copernicus Emergency Management Service. I would like to share our experience with the use of drone imagery, not an autonomous network like you presented, but a classical network of operators all over Europe, because we realized also that with Earth observation data, satellite data, now I have to be very careful. So with satellite-based Earth observation, we have often problems with cloud, etc. Resolution not enough. So this is where we have set up also now a network of drone operators all over Europe. There's now several hundred drone operators that are registered with the Copernicus Emergency Management Service, and that can then be triggered in case there's a need after a disaster somewhere in Europe. But that's not enough, because as you mentioned, there's also strict regulations, there's safety regulations. So there's this specific operations risk assessment, as we call it in Europe, where you have to, for each flight, commercial drone flight, you have to get authorization from the flight safety agencies, etc. So quite a complex situation that, again, you cannot solve when you need imagery very quickly. So what we were doing there, and that's maybe something that also needs to be done in the context of GEO, is to really start negotiating with countries that in case of a disaster, we have special authorization for ad hoc drone flights over an affected area that are then obviously coordinated with all the other response agencies in the country. So that's something where I think, yes, it's complex, but I think especially GEO could be a good body for advancing such knowledge and use.
So just building on the remarks that my colleague here made about restricted access to data, one of the things that we've been working on in the in situ data subgroup is to better understand what are the specific barriers to open sharing of data. And we've been trying to actually get a better understanding of why isn't data open and available for sharing. And I think looking at different national policies and also different national policies, how they apply to different types of data and in different scenarios is actually really important. And I wanted to just focus in on the point that you made, because I think GEO has a very unique position in terms of being able to leverage with different government agencies to perhaps promote better and open sharing, particularly of critical data in times of specific need, as you mentioned, after a particular disaster of some sort. So I think part of this conversation is actually really interesting, because we can use potentially this nexus as an example of how we can better understand the specific challenges associated with particular types of data as they are applied for different applications. And I think this is something we should perhaps think of trying to use this nexus activity for, is to understand, is there a way of using this activity to break down some of those barriers to data sharing?
Thank you for the response. Any other?
Can I come back?
Yeah.
Ellen, just based on what you said. So I'm hearing a few things. One is around like existing capabilities, and we've heard some great examples of both satellite-based in situ. Complexity around collecting, sharing that information. And also this perhaps role that we can play. And I'm thinking more about the second two proposed directions here about basically mapping these capabilities back to the specific use cases in which they appear. And maybe, I mean, to try and Thomas, I did like your analogy of Ferrari, and maybe we should be building a Fiat rather than a Ferrari, but it's this complexity issue, I think, mapping it to specific use cases so that somebody coming at the issue of urban coastal resilience and making some specific decisions isn't like then faced with a discussion around why it's really hard to share data, but maybe just initially signposting where useful information is available, how to combine it. But in the process of doing that mapping, we are surfacing some of these bigger sort of structural challenges that the GEO community work program activities working groups can advance. So I think, maybe it's me saying, if I had to pick one or two of these directions, it would be on this mapping simply existing capabilities to decision needs, and in the process surfacing follow-on activities that we all probably know need to happen, but it does certainly in my view, help when you have a concrete example of why these barriers exist. And some of them will be technical, and some of them might also relate to the environments in which these decisions are trying to be made and how data doesn't always underpin all of these very urgent and important decisions that need to be made. And so having that surfaced and captured and stored in the Knowledge Hub, I think, is an excellent starting point.
Thank you. Yeah, looks like there's no way to bring the comments from online participant. So time is, we have 3 minutes left. So we can continue to comment online. So there's a barcode. They will be open for at least 2 weeks. So we can continue to vote and also put your comments there. And we will collect and summarize. Yeah.
Show some of them. That is already.
Oh, really? Okay. Yeah. Put it on. Can you just switch the screen?
Encouraging.
Yeah. Okay. So we can. So if we cannot get the voting result now, and we will continue. So it looks like we already got a lot of voting from online. So I'd like to. Okay, so 1 more week, so we have time. And so I try to summarize a little bit. I think today this is joint efforts. We have 3 working groups and several highly relevant work programs. So the idea is we try to work together to handle the urban risks and solutions. So this is a joint effort across the GEO community. It is not limited to the participants sitting here, and we have a broader community. So this is I would say that this mechanism serves as a glue or bridge. So one side, we have global grand challenges like climate change, disasters, and biodiversity loss. And the other side, we have Earth intelligence capacity. So we can work together, really help to serve and handle the real world problem. And so I'd like to thank all the participants here and the panelists and also the participants in this room and also online. And this is just a start. We just began, and so here we have proposal, so we can start work together and follow up, and we will report back. And then hopefully next year or several months later, we have some more concrete actions. So thank you again for everyone, and yeah, coffee break.
All right, I couldn't be projected, but you summarized it beautifully. Very excited. I think it's a nice niche that we can do.
Can you take a picture? Take a picture, guys.